Hi everyone, Victor here again, and I will be introducing you to the OpenShift Container Platform course. This course is for absolute beginners. It is a well-detailed course that would help you in your OpenShift journey. And for those who will be writing the OpenShift exams, please follow through the OpenShift playlist on this channel to continue with the exam objectives. You can also follow through the documentation on our website, and we also have some exam practice or preparation questions that will guide you in passing the OpenShift exam. You can also check our website as regards that too. More so, we also offer trainings such as RHCSA, RHCE, OpenShift, different OpenShift trainings, Kubernetes trainings, Terraform trainings, and a lot of trainings. You can contact us on info@technip.com if you have inquiries. Thank you. Hi everyone, my name is Victor and I'm one of the authors of TechNid. I welcome you to the OpenShift complete studies and playlist. We will be learning a lot of things, so it's better we just get started. If you're familiar with Docker, Podman, or some other container runtime, you will understand that this container runtime can actually be used to create and run containers. In other words, this container runtime can be used to run containerized applications, which is fine. However, when it comes to automation, orchestration, or management of these containerized applications, especially in their hundreds and thousands, it is never easy and most times not even possible to use these tools. And even especially now that heavy applications like core banking applications are now being containerized. Hence, the need for an orchestration, automation, and extremely high availability tool that can manage rather hundreds and thousands of containerized applications. And one of the two is what we're about to learn now, which is OpenShift. OpenShift is a container application platform. Just like Kubernetes, OpenShift platform orchestrates and manages containerized applications and can be used to easily scale up applications as required. OpenShift was developed by Red Hat. The OpenShift cluster is built on top of the Kubernetes cluster and Red Hat core operating system. It is compatible with Kubernetes, and because it is compatible with Kubernetes and built on top of it, it can be managed the same way with Kubernetes cluster, but this time around by using OpenShift management tools. So permit me to say that OpenShift is just like a distribution of Kubernetes. Before we look at the OpenShift architecture, let's understand some of the Kubernetes components or objects because the OpenShift is built on top of Kubernetes. Let's talk about this Kubernetes object. The first Kubernetes object or component to talk about is the node. Nodes are just servers. It can either be a physical server, that is bare metal, or a virtual server. The second object to talk about is the pod. The pod component is the smallest execution unit in Kubernetes, unlike Docker or Podman where the smallest unit is the container. So pod is an abstraction over a container, and it could be an abstraction of containers such as Docker, the CRIO, the container D. So your container applications will be running inside a pod. And you should also know that you can have more than one container image in a pod. You can have two container images, three container images in a pod, but usually it's always one pod, one container image. But in some cases, depending on your deployment, you may choose to have more than one container running in a pod. So let's talk about the OpenShift architecture. OpenShift Container Platform or rather, OpenShift cluster consists of some number of nodes joined or clustered together. After all, that's the meaning of cluster, joining together of either components or features together. In OpenShift, we basically have the master nodes and the worker nodes, and in addition, we also have the infra node. The master node or the control plane, it is also called the control plane, yes. So it provides the basic services that manages the OpenShift cluster, and the worker node, also called the compute nodes, are where your application resides in. Apparently, since the worker node holds the workload, the worker node resources, that is, server resources, have more resources than the master node. So the infra node, meaning infrastructure node, is used to host infrastructure services such as monitoring, logging, and etc. So in OpenShift cluster, there must be a minimum of at least 3 control planes and a minimum of 2 worker nodes. Now let's talk about the services that must be present in these nodes. The first thing that you must install on every node is the Red Hat Core Operating System, which is the RHCOS. The Red Hat Core Operating System is a container optimized OS, and it consists of the CRIO container runtime. This is the Kubernetes native container runtime, which has replaced the Docker container runtime used in older version of OpenShift. And of course, the container runtime is basically used to run the containers in the cluster. The Red Hat Core Operating System also consists of the Kubernetes kubelet service, and the kubelet service interfaces with the container runtime and the node, and the kubelet service is responsible for starting and running the pod. It can also assign resources from the node to the pod. And another component or another feature that the RHCOS consists of is the ignition. The OpenShift cluster uses ignition as a first boot system configuration to bring up and configure the cluster. The Red Hat Core Operating System also consists of some other sets of container tools. In the previous version of OpenShift cluster, the Red Hat Enterprise Linux operating system can be used as the base operating system, but for the newer versions, the Red Hat Core Operating System must be used, and because the Red Hat Core Operating System is immutable, meaning that you do not have any need to manage the operating system, unlike the Red Hat Enterprise Linux, where you will still have to manage the operating system. Hence, Red Hat has adopted using the RHCOS over the RHEL operating system. And also, even for your worker nodes, you must also make use of the Red Hat Core Operating System. On top of the Red Hat Core Operating System, we have the Kubernetes layer. Don't forget that the OpenShift is built on top of Kubernetes and the Red Hat Core Operating System. The Kubernetes layer consists of the Kubernetes services such as the Kubernetes API, the Kubernetes Controller Manager, Kubernetes Scheduler, etcd, and etc. If you've seen my Kubernetes course, you would automatically understand the responsibilities of these services, but for those who haven't seen, I will explain. So the Kubernetes API is like a door to the Kubernetes cluster. Before you can interact with Kubernetes, you need to come in through the Kubernetes API, which is the door. The Kubernetes API then validates the credentials and does the authentication into the Kubernetes cluster. So let's talk about the Kubernetes scheduler. The scheduler is very intelligent. It schedules which node a cluster component, for instance, a pod will be created on. It knows the right node to schedule pods on, and it does this automatically by default. Also, the etcd is like the brain power of the cluster. Every cluster operation apart from the workload operations are stored in the etcd as logs in the YAML format. Also, the controller manager. The controller manager is responsible for controlling the Kubernetes operations in the cluster. The controller manager watches the etcd for any changes and knows what the desired state is. So it knows what the desired state of your cluster should look like. If the cluster is not in its desired state, the controller manager uses the API to enforce the desired state. For example, if a pod dies, the controller manager signals the scheduler for the pod to be rescheduled and recreated. Then the scheduler signals the kubelet to recreate and start the pod. On top of the Kubernetes, we also have the OpenShift layer. And the OpenShift consists of the OpenShift API server, the OpenShift controller manager, the OpenShift OAuth API server, and the OpenShift OAuth server. There are some other services, but these are the ones we need to start with, at least to get going with OpenShift. So for the OpenShift API server, the Kubernetes API server will talk to the OpenShift API server so that it will proxy request to the OpenShift API server. It validates and configures data for OpenShift resources such as templates, projects, routes, and etc. So for the OpenShift controller manager, this service is responsible for making sure that the OpenShift cluster object is in its desired state. It watches the etcd for changes in OpenShift object and then uses the API to enforce the specified state in the event where there is a difference in the desired state. The OpenShift OAuth is responsible for integrating a method of external authentication. It will proxy external requests back to the OpenShift API server. For instance, users request tokens from the OpenShift OAuth server to authenticate themselves to the API. And for OpenShift OAuth API server, this is responsible for validating and configuring data to authenticate to OpenShift container platform, such as users, groups, and OAuth tokens. So having understood how OpenShift architecture is, in the next lesson, we're going to look at how to install OpenShift. I wanted to say OpenShift Kubernetes as well. So we're going to look at how to install the OpenShift cluster. And so thank you for watching, and bye for now. Now let's look at installing OpenShift Container Platform. Just as Kubernetes, the OpenShift Container Platform can be installed on bare metal, VMs, or as a managed service on cloud. This is a very important lesson because the installation of the OpenShift Container Platform takes a different approach as compared to Kubernetes cluster installation. So please flow along with me. You can ask questions in the description section below or in the comment section on the website. I'll be dropping the link to this website, to this particular lesson, in the description section below so that you can easily navigate on the website and ask your questions, and also you can subscribe to our newsletter for courses like this. So OpenShift has two major installation methods. The first one is called the installer provisioned infrastructure, also known as IPI, and the second method of the OpenShift installation is called the user provisioned infrastructure, also known as UPI. So let's talk about the first one, which is the IPI. From the word installer provisioned, this means that an installer program will be responsible for deploying the OpenShift cluster on an infrastructure the installer program itself will provision and maintain. This is a full stack automation process. This process is fully automated, and OpenShift manages all the cluster aspects, including the operating system itself. Secondly, or alternatively, you can use the UPI method to install the OpenShift cluster if your environment does not support the IPI method. And from the word user provisioned, this means that you, which is the user, will be the one to prepare and maintain the infrastructure the OpenShift container platform will be deployed on. This is also known as pre-existing infrastructure. So in summary, for the IPI method, the installation program provisions and maintains the infrastructure the OpenShift container platform will be deployed on, while for the UPI method, you, the user, will prepare and maintain the infrastructure the OpenShift container platform will be deployed on. And the IPI method is easier than the UPI method. Since the IPI method is easier, I'm sure everyone prefers an easy route to doing things. So at this point, we can use the IPI method of installation. However, and unfortunately, not all environments or platforms support the IPI method. Let's look at the platforms that support the IPI method of installation. So for cloud, the platform that supports the IPI method are AWS, Azure, GCP, which is the Google Cloud Provider, Azure Stack Hub, Red Hat OpenStack Platform, IBM Cloud, VMware Cloud, which is the VMC, and Alibaba Cloud. For virtualization platform, we have the Red Hat Virtualization, VMware, vSphere. And of course, if you don't want to use the IPI method, you can also use the UPI method on this same platform, especially when leveraging on the IaaS, which is the Infrastructure as a Service platform on cloud. If you don't have these platforms, all you have is a bare metal or any unknown platform, you will have to use the UPI method. So you need to ask yourself this important question, which is, what type of installation am I doing? Am I doing installation on cloud, or am I doing the installation on-prem? And of course, if you're doing the installation on cloud, with the platforms that I have mentioned that supports the IPI method, you can use the IPI method of installation. And if you're also doing the installation on-prem, if the platform supports the IPI method, you can use the IPI method. And if the platform does not support the IPI method, you would have to resort into using the UPI method. So moving forward, like I said in the previous lesson, when we were talking about the architecture of OpenShift, I said you must have a minimum of 3 control planes and a minimum of 2 worker nodes to be able to install the OpenShift cluster. So you must have this kind of architecture to be able to install the OpenShift cluster. And in addition to that, OpenShift installation also require using a temporary bootstrap server and a services machine. So in addition, it means that you would have at least 7 servers to be able to install the OpenShift cluster. And hey, come on, I don't have this kind of resources. I don't have 7 physical servers. Of course, I can't afford 7 physical servers for now. And also, I can't even afford to spin up 7 VMs in my environment for now because I have a lot of workload in my environment. Hence, just as we did during our Kubernetes course, where we had to install the single node Kubernetes cluster using Minikube, we will also have to improvise or find a way out by using a single node to run both the master node and the worker node, which means we will need to install a single node OpenShift cluster. From Red Hat perspective, you can install a single node OpenShift cluster in different approaches. You can install one, a single node OpenShift cluster known as SNO using the assisted installer. The assisted installer is a GUI that makes the provisioning or the installation of the OpenShift cluster easier. To use the assisted installer, you need to log into console.redhat.com. You can easily create a Red Hat developer account if you don't have any. This SNO installation method can be used in a production environment. However, there won't be any form of high availability, and of course, which may not be the best practice for your organization. And the minimum requirement for this type of installation is 8 vCPU, 32 gig RAM, and 120 gigabyte storage. Again, I asked this very important question. Do you have these resources? Can your laptop or desktop accommodate this? Because of those who don't have this kind of resources and want to learn OpenShift and use OpenShift for development or testing purposes, Red Hat has also come up with a second approach for a single node OpenShift cluster called 2 Red Hat OpenShift Local. This is formerly known as Code Ready Container. With OpenShift Local, you can install a minimal version of OpenShift on your laptop or desktop. And the minimum requirement for this installation is 4 vCPU, 9 GB RAM, and 35 GB storage. I know someone will be smiling by now because a lot of us have this kind of resources, and for the purpose of our course, for the purpose of this course, we will be installing the OpenShift. We'll be installing the OpenShift local first, and later on, we will also be installing the SNO using the assisted installer. And at the end of this course, I will show you how to install OpenShift using the IPI and the UPI method on bare metal and other cloud service providers. Before I round off with this lesson, let me quickly address the following: OKD and Minishift, Sandbox for OpenShift, and OpenShift on the cloud. So let's start with OKD and Minishift. OKD, meaning Original Community Distribution, it is the community version of the OpenShift cluster. The OKD can be installed on various Linux distributions and it is free. It is free and it can also be deployed for production purposes. At least one can make use of the support from the community, but if you want a professional support, which is the support from Red Hat, you would need to use the OpenShift container platform. And Minishift. So Minishift is just like Kubernetes Minikube or Red Hat OpenShift Local. The Minishift helps to run OKD locally on a single node, and this is a single node OKD cluster where both the master node and the worker node will run on a single node. So the second one is Sandbox for OpenShift. With Sandbox for OpenShift, you can use OpenShift without setup or configuration, and it is free. More so, several developer tools are pre-configured for you using Sandbox for OpenShift. I'm sure a lot of the developers like to hear this. And the third one, which is OpenShift on the cloud. At the beginning of this lesson, I mentioned that OpenShift can be installed on the cloud as IaaS, which is infrastructure as a service, and as a managed service on the cloud. Yes, this is true. OpenShift can be installed on the cloud as a managed service where the cloud provider, for example, Azure and Red Hat, will jointly manage the OpenShift container platform for you. OpenShift can also be installed on the cloud as OpenShift dedicated, for example, on AWS and GCP, where OpenShift will be managed by Red Hat, and OpenShift can also be installed on the cloud as OpenShift Online. OpenShift Online is the Red Hat public cloud. It's the Red Hat public cloud application development and hosting platform. We have discussed a whole lot of things. So in summary, we have talked about the installation of the OpenShift container platform using the IPI and the UPI method. And we also said that the IPI method is only available for some platforms on cloud and on-prem. If your platform does not support the IPI method, you will have to use the UPI method. We also discussed the single node OpenShift cluster using the assisted installer and using the OpenShift local. We also discussed the OKD and the Minishift. OKD, which is the community version of the OpenShift, and Minishift, which is used to run the single node OKD cluster. And we also discussed about the sandbox for OpenShift, which means you can use OpenShift without setup or configuration. And lastly, we discussed about the several approaches as regards the OpenShift on cloud, which includes the IaaS, which is the infrastructure as a service, which also includes the managed service. It also includes the OpenShift dedicated and OpenShift online. So I hope I've been able to do justice to this lesson. And I want to say thank you for your time. Thank you for watching. Please like, share, subscribe, and comment. If you do this, you would help us to, you will encourage us to always make good courses as this. So I'll see you in the next lesson. Bye for now. Hi everyone, Victor here again. Welcome to the next lesson, which is installing Red Hat OpenShift local. In our previous lesson, we discussed the installation methods of OpenShift, and you and I agreed that we will start with the installation of the OpenShift local. OpenShift local, also called Code Ready Container, can be installed on Linux, Windows, and Mac OS, and can only run with the network manager, and can also only run on hypervisors, just like the Kubernetes Minikube that runs only on hypervisors. To be able to interact with OpenShift, we need an OpenShift client tool, one which is the OC, meaning OpenShift client. And fortunately, the OC is installed alongside with the OpenShift local. Because I would love to use Linux and I'm a Red Hat guy, hence I'll be doing this installation on RHEL 9. This same installation can be done on RHEL 8 and RHEL 7 systems, and we already discussed the requirements for your hardware or VMs in the previous lesson, which I'll be dropping the link in the description box below. And if you also have any question, just please ask me in the comment section below, or you can go to the website. I'll also be dropping the link to the website in the description box below. You can also ask me your questions there. So let us look at the step-by-step guide of how to install the Red Hat OpenShift local on Red Hat Enterprise Linux 9 system. Currently, this is a Red Hat Enterprise system, so I'm just going to be using the KVM hypervisor, and for RHEL 9, I will need to install the KVM hypervisor. So to do that, I'm going to install the KVM hypervisor by using this command here, and this is going to install the KVM hypervisor. Like I said, I'll be dropping the link to the website in the description box below, so you can easily copy and paste if you don't want to type like me. This is done installing, And now we can start the library.d. So the daemon is going to be started. We can just check the status of the hypervisor. So you can see that it is active and it is running. Vert-D automatically comes with the full installation of Red Hat Enterprise Linux 8. So all you need to do if you're using RHEL 8 is just to install the additional package and you restart library. So now that we have this, we can download the OpenShift local, which is also called the CRC. So I'm just going to copy the command and I'm going to paste it here. So this is going to download the OpenShift local. So now I can verify that the OpenShift local has been downloaded. So I can just do ls. So you can see that it's been downloaded. So what I can do now is to extract this file. So I'm going to say extract file verbose in the downloaded file. So you can see that the file has been extracted here. And you can see the CRC, which is the code ready container here. I can make the file executable. I can just do chmod plus X. I can do crc linux 2.5 crc. So if I confirm that, let's see if this has been made executable. So I can do ls-l. So you can see that it's been made executable. Since crc is a binary file, I can just install by moving into the user local bin directory. So I can just say copy or move whichever one I want. So I'm going to copy here. So this is going to be 2.5/crc. I'm going to move this to usr/local bin. So I can verify that it's been installed by just doing crc version. All right, so you can see the CRC version, you can see the OpenShift version, and you can also see the Podman version. If you try to run CRC as a root user, it will not run. All right, so we need another user and preferably a sudo user to run CRC. And I already have a user with the name Victor here. So I'm going to make the user a sudo user, and I'm also going to add the user to the library group. So the library group is just the hypervisor or the KVM group. So to make Victor a sudo user, I'm just going to say user mode append g, the group will going to say Victor. So also for the library group, I'm going to say library. So now that I've been able to do this, the next thing to do is to log in as the Victor user. But before I even do that, let me confirm the changes that I just made. So you can see that Victor is in the wheel group and is also in the library group. And to log in as the Victor user, I can just use SSH. It's better you use SSH to log in and not switch user because of the path, So, and if you don't want to use SSH, you can just do some sort of fresh login, So I'm just going to SSH to localhost. I'm going to say yes. I'm going to put in the password for Victor, and now you can see that I've been able to log in as the Victor user. So the next thing I'm going to do is to initiate the OpenShift local or the CRC setup. So the CRC setup will, if I initiate the CRC setup, it will download the CRC bundle, and the CRC bundle contains the VM image for the OpenShift cluster that will run in the KVM hypervisor. So I'm just going to do CRC setup. I'm going to say it's asking me if I want to contribute anonymous usage. I don't want to do this. So I'm going to put in the password for Victor. And then let's see what going to happen here. So it's beginning to download the CRC bundle. So you can see here. So what I'm going to do is to it's a whole lot, about 3.13 gigabyte. Wow. So what I'm going to do is to just pause the video, and when the download is complete, I'm going to resume the video. So you can see now that the CRC bundle has been downloaded and it has been uncompressed. And you can see here now that it's saying that your system is correctly set up for using CRC. Use CRC start to start the instance. Excuse me, so let me just clear the screen, and I'm going to say CRC start so we can start CRC. And while starting CRC, it's going to prompt us to input the post secret. I'm going to be dropping the link to this website where I talked about post secret. So for you to be able to get your post secret, you just need to register. You need to sign up with Red Hat developer account. When you have that account, you'll be able to log into console.redhat.com. Like I said, I'll drop that link in the website. So when you click that link, it will tell you, it will take you to where you're going to get your post secret. So it's just a very easy step. Just one click, then you'll be able to get your post secret. It's no big deal at all. So I'm going to input my post secret here. I'm going to say enter. Please enter the post secret. Okay. I'm going to copy the post secret again, and I'm going to input it here. All right. I hope I didn't do it twice. Okay, so I did it once, and now you can see that the CRC VM is starting for OpenShift 4.10.18. So I'm going to wait for this to start. I don't know how long it will take, so I'm going to pause the video, and when this is done, I'm going to resume the video. So it's still saying that it's waiting for the Cube API server availability, and it's going to take around 2 minutes. So we're still waiting for this to start fully. I'm still going to pause the video, and when it started fully, I'm going to resume the video. So you can see that the OpenShift cluster has been started, and the server is accessible via this web console. You can log in as an administrator using these credentials, and you can also log in as the developer user using these credentials, and you can also see the commands to configure your shell, because if you don't configure your shell, you will not be able to use the OpenShift tool, the OC tool, right? So now we can verify the CRC status. So we can say CRC status it's still taking its time to show us the status. So we're going to wait a while. So you can see that CRC VM is running while OpenShift is still starting. Probably that's why it's taking time. So we're going to say CRC status again to see if OpenShift has started running. So the OpenShift is still starting. So I'm going to give it some time. I'm going to clear my screen. So let me give it some time, and let's see if the OpenShift has started running so that we can do some other tests. Before I check again, I'm going to make sure that I'm not being prompted for the root password for Victor. So I'm just going to do this. I'm going to check for the parameters. So I'm going to say sudo cat etc sudo as. So I'm just going to copy this one here. So what I'm going to do is I can actually include it here, but I'm going to prefer a drop-in file, which I can include here. You can see here that I can drop it in etc sudo as.d. So I'm just going to say sudo bi etc sudoers sudoers d slash Victor. So I'm just going to drop it here and I'm going to change this one to Victor. All right, so I'm going to save this file. So what I can do now is to check for the status of CRC. So let's see if CRC is running now. I mean, if OpenShift is running now. Okay, so you can see that OpenShift is running now. The CRC VM is running and the OpenShift is also running. If you try this in your environment and it doesn't run, what you can do is to restart the server. By the time you restart the server, it should run. All right. So if you use the OC command too, you'll see that you can't see anything because we've not configured our shell. And in the instruction that was given to us, we need to configure the shell. And to do that, we need to run crc OC environment. I've cleared the screen, but that's the instruction. So when we do this, you would even be able to see so this would set the OC path, and you can even be able to see the export path here as well. You can see here that it says run this command to configure your shell. So I'm just going to copy this command and I'm going to run it to configure the shell. So when I do this and I do OC again, so you can see that the OC command is not working. So we can log into the cluster as admin. We can also log into the cluster as the developer user. So I always clear my screen because I had to make, because of my recorder, I had to make this screen a little bit smaller so that you can be able to see it well. So I'm going to run crc start again so that I can be able to check the login credentials. So you can see that I can log in as this is the username and this is the password. And I can also use this console, this URL rather, to log in. So I'm going to log in as the admin. So I'm going to say OC login -u q admin and the password, which is this. So I'm just going to copy and paste this, and I'm going to copy this as well. Okay, so it's trying to log us in. So it's saying the server uses the certificate, blah blah blah. Use insecure connections. Well, for now, I'm just going to say yes. So you can see that the login is successful and it's saying that I have access to 64 projects. So what I can do as well is to test. We do our testing by trying to get some cluster information. And to do that, I can just say OC get all. So you can see the cluster type, the name, the cluster IP, and the external IP. If I want to get the nodes too, I can say OC get nodes. So you can also see some of the cluster information. You can see that this is working as both the master and the worker node. All right. So what I can do again is to try and log in as the developer. So I'm just going to copy it somewhere here. So like I told you, my screen is a little bit small. So I mean, that's why I always have to clear it though, because I need you guys to be able to see my screen very well. So I'm just going to copy this one here I'm going to try to log in as the user developer, and the password is somewhere here too as well. The password is developer. So I'm just going to type in this one. There's no need for me to copy this. So you can see that I've been able to log in as the user developer successfully. So this is how you configure the OpenShift local. This is how you configure the CRC, yeah, which is the same thing, OpenShift local or CRC. So thank you for watching. Please don't forget to subscribe, comment, like, and share. When you do this, you would help us to do more of this course, and you would even encourage us to keep doing what we're doing. So thank you once more, and I'll see you in the next lesson. Bye for now. Hi everyone, Victor here again, and I welcome you to this chapter, which is deploying your first application on OpenShift using ad hoc. In one of the previous chapters, we learned about some Kubernetes and OpenShift components and features such as node, pods, and etc. In this chapter, we will also learn about some other OpenShift objects or component or features such as project, deployment, deployment config, replica set, and replication controllers. In this lesson, we will be deploying our first application, and as we have learned in one of the previous lessons that your applications or container image resides in a pod. So basically, deploying an application simply means creating a pod. So to deploy an application in OpenShift, the first thing you need to do is to log into the OpenShift cluster. And to do that, you can use the command oc login user, which is the cube admin, and the password, which is -p. So this is the password, and this URL, which is this. So I'm going to be logging in as the cube admin. So if I press enter, so it's trying to log us in. You can see that here it's saying login successful, and it also says that I have access to 65 projects and using project default, meaning that we are using the default project. So what is project? Project is an organizational feature of OpenShift that allows you to group your resources. Some technology will call it organization unit, some will call it resource group, and even in Kubernetes, it is called namespace. And don't forget that OpenShift is built on top of Kubernetes, so you will always get to see this used interchangeably. So I'll be using namespace and I'll also be using project interchangeably. And I'll also be dropping the link to my Kubernetes course in the description section below if you're interested in it. To see all the projects available on this cluster, you can use the command oc project. So you can see that we have a whole lot of projects available, and you can also see that we are using the default project on this cluster. So we have a whole lot of them. If you want to count them, you can just pipe this to the wc command, and you can see that we have about 69 projects, and we have access according to here to this outline. We have access to just 65 projects. You can also see the asterisk here on the default project, meaning that we are making use of the default project. So you can make use of the default project if you want to, but because I don't want to, I'll be creating a new project. And to do that, I can use the command oc new project. So I can give any name of the project I want to give. So I'll be calling this project app project. So it's trying to create a new project. And now you can see that this project has been created. You can see that it's saying that we are now using project app project. And you can also see some other information about the project. And if I want to confirm if this project has been created, I can use the command oc project. So you can see now that it's saying that we're using the project app project. So let's look for the asterisk. You can see now that we have the asterisk on app project. Like I said that deploying an application simply means creating a pod. And there are a lot of ways to create a pod on OpenShift. Just as we learned in my Kubernetes course that a pod can be created as an individual object and by using deployment, the same is applicable in OpenShift. So to create a pod in OpenShift, you can 1. Create a pod as an individual object, and 2. You can create a pod by using deployment, and 3. You can create a pod by using deployment config, and 4. You can also create a pod by using the new app option. I am sure by now different ideas will be running in our minds, like how and when should I know which way is better in creating the pod? Okay, let's break this down. I am going to start with what deployment is. A deployment is a layer over a pod. It's a collection of some set of pods and other resources, and using deployment to create a pod manages the applications or pods holistically because the pod will be managed by deployment accompanied with other resources and features that comes with deployment. And one of these features is the replica set. So the replica set is responsible for the replications or replicas of a pod. So if you want to increase or decrease the quantity of a pod accordingly, the replica set allows you to do that. And with deployment, you don't have to create the replica set features separately. The replica set will automatically be created and managed by the deployment. With deployment, you will also have the benefit of doing an automatic update, pod update, and you can also easily roll back to the previous update if the update is not compatible. On the contrary, creating a pod as a single object will not give you all these benefits of using deployment to create a pod, just like I mentioned. So you can choose which is suitable for you, creating a pod as an individual object or creating a pod using deployment. Well, out of these two ways, creating a pod with deployment is better, finer, fine-grained, and more realistic than creating a pod as a single object. However, there are some tests you might want to quickly carry out. In that sense, we can create a pod as an individual object. Having understood what deployment is, let's understand what deployment config is. Deployment config is an OpenShift object. It is strictly an OpenShift object, and the deployment config object is very similar to the deployment object. They do the same thing, they achieve the same goal, just that they do it using slightly different methods. For example, one of the features that comes with creating deployment is replica set, while that of the deployment config is replication controller. And the replica set and replication controller basically do the same thing and achieve the same goal, which is managing the quantities of pods accordingly. The replica set is just a successor of the replication controller. And the common question I often get is, Victor, do I use deployment or do I use deployment config? Well, Red Hat has advised that we should try as much as possible to always use deployment because deployment serves as a descendant of the deployment config. However, if you need a specific feature of the deployment config object, you can make use of the deployment config. Otherwise, make use of deployment. I won't go deep into their specific features and how their behaviors works for now, but if you are curious to know how they work, I'll be dropping the link in the description section below so you can click on the link and you can learn more about the deployment config. And as we go on in this course, I will show you how their behaviors works practically, probably in the second part of this course. And lastly, a pod can be created by using the OC command with the new app option. This is one of the easiest and arguably the best way of creating a pod in OpenShift because the OC new app command automatically creates a deployment which will be used to manage the pods. In the older version of the OpenShift, the new app option usually creates a deployment config, but in the newer version, it now creates a deployment. And like I've explained, Red Hat advises that we should use deployment at all times instead of the deployment config. And I know by now, someone watching this video is already asking me in his mind that why should I use the new app option to create a pod when I can use the deployment straight away because the new app option also creates deployment. All right, to answer your question, the new app option does not only create deployment, it also creates service for you. And I will talk about what services are in the next chapter. But before the next chapter, we have been doing some explanations since by talking. So why not let's go practical? To create a pod as an individual object, we're going to use the command oc run. So I'm going to give the name of the pod. So I'm going to call the pod Nginx application, and I'm going to say that you should download the Nginx image, and by default, the image is going to be downloaded from the Docker hub. So if I say enter, you can see now that the pod Nginx app has been created. So if I want to get an information about the pod, I can just say oc get pods. So you can see now that the pod is already running. And if I want to get a wider information, I can just say put this output to a wider information. So you can see that this is the name of the pod, and you can see that the status is running. You can see the internal IP of the pod, and of course you can see the node where the pod is running. And don't forget that we are using a single node cluster, meaning that we have both our master node and our worker node running on the same node. So if I want to get more information about this pod, I can say oc describe pod Nginx app. So this is going to give me more information about the pod. So if I scroll up, let's scroll up a bit. So you can see the name of the pod here. You can also see the namespace. Like I told you that in Kubernetes, the organization of resources is done by namespace, and while in OpenShift it's called project. And you can now see that, like I told you, that we're going to be using these names interchangeably. So this is the project or namespace, and the name is called app project. You can see the node where this pod is running on. You can see the timestamp. You can also see the labels. Later on in this course, we're going to talk about labels and annotations. So if you scroll down more, you can see the status of the pod. You can see the internal IP of the pod. You can see the containers that is in the pod. And if you scroll down, you can also see, let's scroll down, you can see the event, which is the logs. You can see that at the time, the image was being pulled and it was being successfully pulled. And you can see that at the time, the container was being created and at the time, the container was being started. And for us to test that the app has been successfully deployed, we need to log in to the node where the application resides. And in our case, it resides on the OpenShift local or CRC node. And just to reiterate the architecture we are using in our course again, we have our VM, or yours might be a physical laptop or a desktop, which is an external node to the OpenShift local or CRC node running as a VM in our hypervisor. And we are using the KVM hypervisor in this case. And it is in that CRC VM that the OpenShift cluster is deployed on. So to be able to do our test, we need to log into the OpenShift local or CRC node or VM. And to get the CRC node IP, we can use the command oc get nodes. All right, I can only see that we have the CRC node, of course, which is running as both the master and the worker, but I can't get the IP here. So I think CRC IP should be able to give me the IP of the CRC node. Yes. So you can see the IP of the CRC node here. So we need to log in into this node. And before I log in into this node, I need to get the IP of the container or of the pod again. So if I do this command, you can see the IP of the container or pod here. So what I'm going to do now is to log in into the CRC node. So with this command, I'll be able to log into the CRC node. And what I'm going to be doing is I'm going to be dropping the link to this particular lesson, the documentation link to this particular lesson in the description box below, so you can easily click on it and do a copy and paste like I've done. So what I just did is to SSH into this node. You can see what I did at this node IP and as the user core. And that's what I'm going to be using to log in into this CRC node. So if I press enter, so we are logging in into the node. So you can see now that we've been able to log into the CRC node with this IP, with this core user, and we are in the node now. And what I'm going to do is to do my test. And so if I do call on the IP of the pod, so I'm just going to copy this IP and I'm going to paste it here. So now you can see that we can get the output welcome to Nginx, meaning that the Nginx application is successfully deployed. If you understand normal basic web application like Nginx or Apache, whenever you want to do your test, when you get sweet outputs like this, it means that you have done the right thing. And I'll also be dropping the link to the basic Apache and Nginx configuration. If you wish to learn about it, I'll be dropping the link in the description section below. And if you remember correctly, in one of the previous chapters, I told you that the default container runtime that the OpenShift uses is the CRIO. And of course, you can also check the other containers that are running in this container runtime. So for example, if I want to check, I can just say sudo crictl, which is the client that is always used to query the CRIO container runtime. Unlike Docker, of course, you use the Docker, and for Podman, of course, you use Podman. But for CRIO, so I'm going to be using CRICTL, so I can check the containers that are running in this container runtime. And you can see that we have a whole lot of containers running in this container runtime. We can also check for we can grep for the container that we just created, which is Nginx. So you can also see that the Nginx container is running in here and is running for about 35 minutes ago. So now I can exit out of this node, and then I am back to my VM, and yours might be your physical node. So we are back to our rather external node. Having learned how to create a pod as a single object, now let's learn how to create a pod using deployment. So what we're going to do is to clean up this environment by deleting the pod that we just created. So if I say get pods, we created the Nginx app pod. And before I delete this pod, I want to quickly do something. Okay, I want to do call to this IP address. So you can see that we are not getting any output. I want you to put this information on your right palm. We're going to explain what's happening here in the next chapter. So now let's delete this pod that we just created. And to do that, I'm going to say delete pod nginx app. So you can see that the pod has been deleted. Okay, let's wait for the cursor to drop down. All right, so now I'm going to confirm if we have any pod running on this cluster. So I can say get pods. So you can see now that it's saying that no resources found in the app project namespace. Don't forget that we are, of course, using the app project namespace, which we have created. Let me just clear my screen, and now let us look at how to create a pod by using deployment. To create a pod by using deployment, use the command create deployment, and you give the name of the deployment. In this case, I'm going to say Nginx app, and I'm going to say that it should pull the image. It should pull this Nginx image, and like I said, that the image is going to be automatically and by default pulled from the Docker hub. And if I say enter, you can see now that the deployment Nginx app has been created. So if I say get deployment, you can see now that the deployment has been created. However, of course, the deployment is ready. However, the container is not running yet. And if I say get deployment again, you can now see that the Nginx container is now running inside of this deployment, and the deployment is going to be used to manage the Nginx pod. So if I say get pods, you can see that the pod has been created, and it's giving it at the suffix, it's giving it a random name, but for the prefix, it's telling you that this pod was actually created from creating this deployment, and that means that the pod is going to be managed by the deployment, and you can see that the pod is running. So if you want to get more information about the pod rather, so you can just say get pods wide, So this is going to give you the internal IP of the pod, and it will also give you the node where the pod is running on. And of course you can say also describe pod. So I need to copy the name of the pod. So this is going to also give you information about the pod. And if you scroll up here, let's scroll up, you can see that the namespace is app project. This is the node, this is the start time, labels, annotations. I'm trying to get something here. Let me scroll up a bit. Oh, okay, so this is the information about the pod. I was trying to get the deployment. So I want to say OC describe deployment nginx app. Oops, OC describe. Nginx app. OC describe deployment. What's it saying? Deployment.apps not found. OC describe deployment. So what deployment did we create then? OC get deployment. Oops, I didn't I didn't have the hen here. Okay, so this is the deployment we created. All right, I just want you to see some information about the deployment here. So you can see the name of the deployment, the namespace, the labels, like I said, when you create a pod by using deployment, it comes with the replica set. So you can see that we have the replicas here, we have the strategy type, we have the labels. We will talk about labels, we'll talk about selector later on in this course. So this is the information, this is the logs that we got when we were creating the deployment. So this is the way you can create a pod by using deployment in OpenShift. So what I'm going to do now is to clean up this again, and we are also going to look at how to create a pod by using the deployment config. So I'm just going to say OC delete deployment nginx app. So if I say OC get deployment so you can see that we don't have any resource anymore. And of course, if I say OC get pods, you can see that we don't have any resources here anymore. So now let us look at how to create a pod by using the deployment config. To create a pod by using the deployment config, you can just use the command OC create deployment config. I can just shorten it as DC, and if you wish to type, you can just write deployment config. So I'm going to call the name of this deployment config nginx app, and I'm going to say you should pull the nginx image. So you can now see that the deployment config has been created. So if I do OC get deployment config, you can see that I have the deployment config being created. And if I say OC get port, so you can see now that, so this is what is happening. The deployer pod is running, and now this pod is being created, which is the nginx app. So we're going to wait for this nginx app to be fully created. And now you can now see that the deployer pod has completed, and now we have the nginx app running here. So if I want to get more information, of course, I can say OC get pods wide. So you can see the IP address of the deployer pod. You can also see the IP address of the pod, of the Nginx pod that is running. So for deployment config object, it can have at most one deployer pod running. Otherwise, multiple deployers end up conflicting. So if I want to get the description of this guy, I can say also describe deployment config Nginx app. So if I scroll up, you can also see the information here, the selector, the replicas, of course, one. You can see the labels here. So I can scroll up and scroll down. And of course, if you can always log into the CRC node and then check if Nginx was properly created or properly deployed. But because we've done that, when we created a pod as a single object, so just to save time, I'm not going to do that any longer. So now let's clean up this and let's see how to create a pod by using the new app option with the OC command. So for me to clean up this, I'm just going to say OC delete deployment config nginx app. So you can see that the deployment config has been deleted. And if I say OC get deployment config, I can't see this anymore. And if I say OC get ports, let's see, I can't see any ports here any longer. So what we're going to do lastly in this chapter is to create a deployment by using the OC new app command. And to do that, we use the command oc new app image. I want to pull the nginx image and I'm going to give it a name, nginx app. So it's creating, it's telling us some warnings. All right, so you can see here, found container, blah, blah, success, run OC status to view your applications. So to be able to see that this has been created, so I can say OC get pods. So you can now see that the pod Nginx is running. And like I told you that the OC new app command will automatically create a deployment for us. So if I say OC get deployment, so you can see that we have the Nginx app deployment. And also I said that the OC new app command would also create a service for us. So if I say OC get service, you can see that we have a service type, which is the cluster IP service that the OC new app command has created for us. And that was why I said that arguably OC new app is the best command to use to create a pod in OpenShift. And of course, if you want to get more information about the pod, you can say also describe the name of the pod. And if you want to get more information about the service, of course, you can say OC describe. So service, I can just use the shortening form of SVC, and I'm going to say Nginx app. So it's also going to give you the information about the service. And also, you know that before we can log into this, before we can do our test, rather, we needed to log into the CRC node. And I must tell you that doesn't make sense. Um, for people to be able to connect to your applications, to your web applications, they don't have to log into your node for them to be able to access your web applications. So in the next chapter, we're going to see how to access an application externally where we don't have to log into the node where the application resides before we can access the application. And that boils down to understanding what service route is and how the networking technology of OpenShift works. So thank you for watching, and I plead that you should please, what am I saying? Okay, I plead you should subscribe to this channel, like, share, comment, and if you do this, you would encourage us to do more of this video. And thank you for watching once more, and bye for now. Everyone, Victor here again, and in today's lesson, we'll be learning about one of the Kubernetes and OpenShift components called service. Before we learn about service, I will create a pod and increase the quantity of the pod so that you can have clarity on what I'm about to explain. So to create a pod, of course, I'm going to do oc create deployment nginx app image equals nginx. So you can see that the deployment has been created, and if I do oc get deployment, we already have the deployment created, but the pod is not running yet. So if I do oc get pods, so the container is still creating. So that's the status we have here. So I need to keep checking. So if I wish, I can just add the watch option. So we can see now that the container is running. So if I cancel this and do oc get pods again, so we have the container running. So what I'm going to do is to create replicas of this container. So I want to increase the quantity of the pod. And of course, currently we just have one pod running from this deployment. And to increase the quantity of the pod, I can easily use the command oc scale deployment nginx app replicas. So I'm going to increase this to 4. So you can see now that this deployment has been scaled. Of course, we're scaling up, and if I do oc get pods again, you can see that they are being created. You can see here the status is saying that container creating. If I do oc get pods again, you can see that all the 4 pods are running. They are the same copies, and they are just inside of one deployment, and these pods will be distributed across different nodes. And in our case, the crc node, since we are running a single node cluster. And if you do oc get options or wide, you will see the different IPs of the pod. You can also see that they are running on just this single node, which is this crc node. And it being we have the production architecture like this, you will see the nodes, like for example, worker node 1 here, worker node 2, worker node 3. You will see that the pods will be distributed across the number of nodes, the number of worker nodes you have in your cluster. But since we are just using a single node cluster, of course, they will be running on the same node, since the node is working both as master and worker node. If you log in into any of these containers, you will be able to successfully verify that nginx is correctly deployed, just like we did in our previous lesson. So now what I'm going to do is to scale down this pod. So what I'm going to do is to just scale it down to 2 pods. So from replicas of 4, I'm going to say 2. And now you can see that it's been scaled. And if I say oc get pods again, you can see that 2 ports out of 4 ports are being terminated rather, and the status is terminating. So if I run this command again, these ports are still being terminated. They're not done yet. And if I run this command again, let's see. So you can see now that we have just 2 ports running, and this has been scaled down to just 2 ports. This is one of the benefits of using deployment to create a pod. OpenShift will automatically do the scaling and automatically identify which node to add the replicas of the pod to and which nodes to remove the replicas of the pod from. Also, these internal IPs are automatically given to these pods by OpenShift. Having understood how to use ad hoc to increase and decrease the quantity of a pod, now let's understand what service is. In our previous lesson, we learned how to use ad hoc to create pod, and we also deployed a basic Nginx application. However, we could only connect to this containerized application, or rather to this pod, by having to log into the worker node where the pod resides, and in our case, the CRC node, before we were able to access the application. And at the end of the lesson, I mentioned that it doesn't make any sense to always have to log into the node before an application can be accessed. It is impractical, hence the need to create a service. You see, pods in nature, they are ephemeral, meaning that pods can die easily. And when a pod dies, of course, it dies with its internal IP address. And when the pod is being rescheduled and being recreated automatically, the pod loses its static IP because the pod IPs are always dynamically and randomly generated by OpenShift. Hence, other components or applications that are meant to talk to the pod will not be able to talk to the pod because another IP may have been randomly assigned to the pod. So to avoid this problem, Kubernetes and OpenShift uses a common or a component rather called service. The static IP address or addresses are assigned to a service instead of a pod, and the service sends the request to the pod. So a service can also act as a load balancer by load balancing requests and sending them to the appropriate or less busy pod depending on the request. Service gives you access into a pod via an IP address and port. Service is not ephemeral in nature, that is, a service doesn't die, or as some gangsters would say, a service doesn't go down easily, unlike pods. So there are 2 types of services, and they are the internal service and the external service. The internal service is used for internal communication within the cluster and doesn't expose ports or application to the external or outside world. It is good to use this type of service if you don't want your applications, especially databases, to be exposed to the outside world. And the internal service is called the cluster IP. The cluster IP will be attached to a deployment at the point of creation, and this IP will automatically be generated by OpenShift. So let's say you created a deployment which has 3 replicas of a pod. Instead of having to query just one single pod, the cluster IP can be created. Hence, you can direct your request or query to the cluster IP, and the cluster IP will forward the request to any of the pods and also do the load balancing among the pods. It can forward the request to the less busy pod, and this is one of the automated and load balancing features of Kubernetes and OpenShift service. Now let's see this in practical. Currently, we have 2 pods running, on this system, and we have one deployment. So you can see the IPs of the pod. And for us to be able to test our Nginx deployment, just like we did, we need to log into the CRC node. And to do that, I need to get the CRC IP. So with the CRC IP, I can SSH into the CRC node. So I'm just going to copy the command from the website and paste it here. Like I said, I'll be dropping the link to the documentation in the description box below so that you can also easily navigate on the website and click on whatsoever you want to click on instead of typing. So now we are already logged into this CRC node. So if I do call to do my test, like I said, this pod, they are the same copy. So if I do call on this internal IP of the pod, you can see that I am getting a result. I'm getting the welcome result. If I also try it on this IP as well, let's try it on this IP as well. So you can see that we are also getting a result. I'm going to log out of this node. And now if I do OC get service, you can see that we don't have any service on this cluster currently. So to create an internal service, we're going to use the command OC expose. So we're exposing the deployment. So I'm going to say OC expose deployment Nginx app, and I'm going to say port equals 8080. So I'm exposing this deployment to port 8080, and the target port is going to be port 80, and that is because by default Nginx uses port 80. So the target port is port 80. So we're going to be exposing the port 80 on Nginx to port 8080. And if I say enter, you can see that it's saying that this deployment has been exposed, meaning that the service has been created. So if I do OC get service, you can now see that we have a service, and the service type, like I said, is the cluster IP. And you can see the IP here, and you can also see the port here. So because this is an internal service, if I try to do call on this service with the IP, with the port number, say port 8080, you can see that I cannot get a connection, and that's because this service is internal and it is not external. Even if I do CRC IP and I do call to the port where the to the node rather where the port resides, and I do 8080, you can see here that we have failed to connect to this, and that is because this is an internal IP and it only allows communication within the cluster. So of course, again, for us to be able to do our test, we need to log in into the CRC node, and to do that, I'll just use this command, and I can now do call on this internal IP, on this cluster IP rather. So I'm just going to say call here, then I'm going to say 8080. So you can see now that I have an output. So let's log out of this CRC node. And if I also want to get wider information about my service, I can do OC describe service Nginx app. So this will give me more information about the service. You can see the namespace, which is app project. You can see the labels. So in the next chapter, I would explain what labels, selectors are. So you can see the type of the service, which is the cluster IP, the target port, the port, the event and the IP here. So this is how you're going to create an internal service in OpenShift. So now let's talk about the external service. The external service is used for external communication, and it exposes ports and applications to the external or outside world. Of course, your web applications need to be exposed to the outside world so it can be accessible by the users. So you can create an external service for this use case. And there are two types of external services. We have the option to create the node port, and we also have the option to create the load balancer. So the node port external service opens an application to the outside world through the node the pod resides in, and that is why it is called node port. So when a deployment is being exposed through a node, one would have to access the application using the node IP and a port. So let's see this in practical. What I'm going to do is to delete the service we just created. So I'm going to say also delete service nginx app, nginx, nginx app. So it's taking its time. So if I say OC get service, so you can see that we don't have any service here anymore. So I'm going to create the external service, the node port external service. And to do that, I'm going to say OC expose deployment nginx app and the type of service, which is node port, and this is going to be port 80. So we are getting an error here, which is saying unsupported value. Oops, okay, this is supposed to be node port. This is supposed to be in uppercase. So you can now see that this service has been created. So if I do OC get service, you can see the type of service, which is node port. So this is the node port external service. And like I said, you can only access the pod through the node where the pod resides, and the pod resides in the CRC node. So if I say CRC IP, so I can see the IP here, so I can now say I can say call rather on this guy, and I can use the random port which the service has given us. So normally you can always specify a port, but just for this use case, I'm going to be using the random port that has automatically been given to us. In the next lesson or in other lessons, we're going to look at how to specify a port. And if I say enter here, you can now see that we are getting the output that we want to get, which is welcome to Nginx. I can also do this on the web browser. So on the web browser, I can copy and paste. Let's see, did I copy it? So I can copy and paste the CRC. Oh, I didn't copy, so let me just type the IP address, which is 192.168. Let me check again. 130.11, and the port is 30300. So we're waiting for the output. And now we have the output we want to see, which is welcome to Nginx. So going forward, let's talk about the load balancer external service. The load balancer external service is mostly used on cloud, And the cloud service providers are the ones who provide this load balancer IP. Unlike the node port external service where requests are made through the node where the pod resides, in this case, the request will be made to the load balancer IP instead, and the load balancer balances the load among the nodes and sends requests to the appropriate pod accordingly. Now let's create the load balancer external IP. First, I'm going to delete the service, the node port external service that we created. So I'm going to say also delete service nginx app. Oops. My cluster is beginning to become unstable. So I'm going to try this again. And now you can see that the nginx app service has been deleted. So to create the load balancer external service, I'm going to use the same command, which is oc expose, but this time around, I'm going to call this type is going to be load balancer. So you can see that the service has been created. So if I say oc get service, you can see the service type to be load balancer, and you can also see the IP, but you can see that there is an external IP that is pending, and this is pending because we are not making use of a cloud service provider. Like I said, this deployment is happening on premise and it is OpenShift local node. If we were using a cloud service provider, the IP address would have shown here where we have pending. The cloud service provider would have given us the IP address. When you connect to that same IP address that you have, you can always connect to any of the pods. So this is how to create services in OpenShift cluster. This is one of the basic networking technology in OpenShift. And before I round off with this course, or with this lesson rather, I'd like to quickly do something. So I'm going to just delete all the resources I have. So to make it easy for me, I'll just say oc delete all all. So this will delete all the resources I have in this namespace. Now that I have all the resources deleted, I'm going to create another pod using the OCNew app. Here. So image is going to be nginx name equals to nginx app. All right, so this is going to create another pod. So it's taking its time. All right, we have it being created. So if I say oc get, so like I mentioned in the previous lesson, this is going to automatically create a deployment for us. So if I say oc get deployment, I have the deployment. If I say oc get pods, so I have the pod and it's been, you can see status here, which is saying container creating. But while this is creating, this is what I want to drive out here. I told you that one of the best ways to create a pod or to deploy an application in OpenShift is by using the OCNew app command, because this will automatically also create a service for you. So if I say oc get service, so I'm sorry guys, I need to leave very fast. So oc get service, you can see that we have the IP being created for us. We have the service rather being created, and you can set the type of service, which is the cluster IP. So this is just what I want to bring out here. And I want to say thank you for watching. I want you to please subscribe, like, share, comment, and yeah, share. Thank you once more. I'm going to see you in the next lesson. Bye for now. Hi everyone, Victor here again, and in today's lesson, we will learn about one of the OpenShift resources called route, and we will also learn how to create it. In our previous lesson, we learned how to create service in OpenShift, and we created both internal and external services. And one of the external services we created is the node port. We were able to access our application externally by using the node IP address of where the application was running. Now let's take this scenario. Let's say that my application is a web application, a customer facing application, and an e-commerce one for that matter. For example, Amazon. Would the users use the IP or node information to log into the web app? Apparently, no. Hence, the need to create a route. So with route, users will be able to externally access the application. Hence, route is used to expose applications for external access or to external networks. And to create a route, we need to expose the service because route is associated with service. So for example, if we have pods, then service. To externally access the pods or applications, we need to create a route. The route will expose the service and create a DNS name so that the application can easily be accessible by using the domain. And by default, route generates a DNS name in the form route name dash project name dot default domain. The default domain can be changed, and it is defined in the routing config section of the OpenShift configuration file master.config.yaml, and we will look at how to do that in other lessons. So basically, service is meant to be used internally by the pods and other resources, and route exposes the service externally to clients or users. Another OpenShift or Kubernetes resources that work similarly like route is ingress. An ingress is actually a Kubernetes resource, and route and ingress allow certain types of traffic. Some are HTTP, HTTPS, TLS with SNI, that is server name identification, and TCP UDP sockets. So meaning you can either expose the service in a secured way or in an insecured way. Hence, routes can be secured or insecured. Insecured route doesn't do any form of encryption when there is data transfer or traffic. Of course, no SSL or TLS certificate, so there can't be any form of encryption, while secured route encrypts the traffic from the client to the route and also from the route to the pod. Let's understand this better. In OpenShift, there are three ways which routes can be secured, and they are edge, pass-through, and re-encryption. So what is edge route? Let's use this topology for explanation. With edge route, there is only a level of traffic encryption between the client or user and the route, and that's where it stops. No form of encryption between the route and the application ports. So TLS only happens between the client or user and the route and terminates before the traffic is routed to the pod. And because for edge route, TLS traffic happens and terminates at the router, the TLS certificate for edge route will be configured when creating the route. Otherwise, OpenShift will automatically assign its own certificate, that is, self-signed certificate, to the route. The second type of OpenShift secure route is pass-through. With pass-through, route With pass-through routes, there is a level of traffic encryption between the client and the router, and also from the router to the application ports. TLS happens all through. No form of TLS termination all through from the router to the pod. And because for pass-through routes, TLS traffic does not terminate at the router, the application will be responsible for assigning TLS certificates for the traffic. The certificate can simply be mounted as a secret volume to the application pod. And the third type of OpenShift secure route is re-encryption. With re-encryption, with re-encryption route, there is full encryption from the client to the pod, just like pass-through. But the encryption from the client to the router is different from the traffic encryption from the router to the pod. So you might have different certificates for the re-encrypt route. So having understood routing in OpenShift, let's see the step-by-step guide of how to create this route. So we are going to be creating an insecure route first. And to do that, I'm going to log in as the kubeadmin user, so I can just say crc start to get the credentials again. So I can say oc login user name kubeadmin and password. I'm just going to copy the password here and paste it here. So you can see that I've been able to log in and I'm using the project app project. And what we're going to do now is to create a pod. And like I explained in the previous lessons, that when you use the OCNew app command to create an application, it will create both deployment and service for you. So we're going to be using the OCNew new app command to create the Nginx application or pod. And to do that, I can just say OCNew app. The image is going to be Nginx, and the name I'm going to call this pod is going to be Nginx app. Alright, so we can verify that this has been created, so I can just say oc get pod. So you can see that the pod is running, and of course if I say oc get deployment, we have the deployment, and like I said, the OCNew app will create the service for us. So if I say oc get service, we also have the service. So we're going to be creating an insecure route first, which means that we're going to expose this service. And to expose a service, to create a route, we will just use the command oc expose service, then the service name, which is Nginx app. So you can see that it's saying that this service has been exposed. So if I say oc get route, so the cluster is beginning to become unstable. So I'm going to try this command again. So I'm going to do this again. You know, it's just the nature of CRC sometimes to always do this. So I'm going to say oc get route. Now we have the route. So I had to cut off some parts of the video while I was trying to make sure the cluster is back up. So I'm going to run oc get route again. So we have the route, which is, let me try and expand this screen. I'll run oc get route again. So you can see the name of the route, which is also the name of the service, Nginx app, and you can see the service name in the next app, you can see the port, and you can see the URL. And like I said, that it would always take, when I was explaining the default URL for route, I said it would always take the route name, which is this, dash the project name, which is this, dot the default domain name, which is this. And of course, in production environment, like I also explained, you would always want to change the default domain name to what is suitable to your environment accordingly. But for the default, this is what you're going to be having. So if I say call on this route, so you can see that I have my welcome to Nginx outcome, which means that I am able to access the application. And if I also do this on the URL, sorry, I mean on the web, let me bring up the web interface. I'm just going to copy and paste the route here. So you can see that I can access this application, this Nginx application. So this is how you're going to create an insecure route in OpenShift. What I can also do is, so let's delete this route. Also delete route Nginx app. So if I don't want to give the name of this route to be Nginx app, I can also change the name. And to do that, I can just say, let's run this command again, oc expose. So I'm going to say oc expose. Where's our oc expose command? Oc expose service Nginx app, which is the name of the service, and I can say name. I can just give the route any name I wish. So let me just say I want to give the route name tech, for example. I can just say tech, and so if I do oc get route, so you can see that the route name is now tech, and it's going to take, of course, the default, which is tech app project.apps. So this is the default domain that I have in my environment here, which might be different from yours if you're not using CRC. And another thing I can do is, let's delete this again, also delete route. So I can also specify, okay, so we changed the name to tech. All right, so I can also specify the host name. So I can say OC expose service Nginx app. So I can just say dash dash host name. So I can just give any host name. I can say web. Of course, it has to make sure that it's being resolved, that the DNS is working well in your environment. So I can just say web dash app project. I can say that, so app project dot apps dash crc dot test, because this is what is being resolved. This is what is resolvable in my own environment. So I can say yes. So if I say oc get route, so if I say call, let's try this. So could not resolve, so I did not get the name right. It's supposed to be testing. So oc expose, instead of test here is testing. So if I say oc get route, and I say call testing here, So we have, yeah, this is what I'm looking for. So we can access the application. So this is how you're going to create an insecure route in OpenShift. And thank you for watching. In other lessons, we're going to look at how to create the other types of secured routes in OpenShift. And please don't forget to subscribe, like, share, and comment. And bye for now. Hi everyone, Victor here again, and I welcome you to this lesson, which is creating and managing Kubernetes OpenShift objects by using the declarative approach. And the declarative simply means, hey, come on, this is what I want to do. This is the end result of what I want to do. I don't know how you're going to do it, but I just want you to do it for me. So you're just declaring the end result of what is going to be done. And the language we're going to be using for this declaration is YAML. So we're going to be working with the YAML configuration file. So in this lesson, you will learn some Kubernetes or OpenShift resources such as label, selector, template, and annotation. In previous lessons, we have always created our Kubernetes OpenShift component by using the imperative approach, that is, by using ad hoc. And like I said, ad hoc simply means basic commands. And really, in the production environment, it is impractical to always use these basic commands to create Kubernetes objects. Kubernetes objects are always created by using the declarative approach, that is, by using the YAML configuration file most of the time, because the YAML configuration file simplifies deployment and the features that is required for this deployment. I mean, all the features can be added to the YAML file at once, and this can be easily applied without breaking a sweat. And more so, the YAML file can be integrated into your code, which makes deployment more easier. So in this lesson, we will look at how to create some of the Kubernetes objects such as pod, deployment, and service by using the YAML configuration file. YAML is an human-readable language, and it contains easily readable syntax. Hence, your code can become your documentation because they are easy to read. The YAML syntax is written in the form of a key-value pair, and the heartbeat of YAML is indentation, that is, child-parent relationship with white spacings. It's all about nesting parameters. And this indentation is very important when it comes to YAML because when you miss it, it means that your code will not run. Never mind, and don't worry, if you don't really understand YAML, you will understand better as we go on in this course. In Kubernetes and OpenShift YAML configuration file, there are basically 5 parts, which are the API version, kind, metadata, spec, which is specification, and status. So let's start with the API version. Every Kubernetes or OpenShift object have their different types of API version. For pod, the API version is v1. For deployment, the API version is apps/v1, and for service, the API version is v1. So this is a key, while this is the value, hence the word key value pair. So that's for the YAML. When you're writing a YAML, like I said, it's always in the key value pair format. The second part of the configuration file is kind. The kind key or parameter is the kind of resources you want to create. So for pod, the kind of resources will be pod. For deployment, the kind is deployment. And for service, the kind is service. And the third part of the YAML configuration file is metadata. The metadata is the data or information about the resource you are creating. One of the parameters in this section is name. Here, you will specify the name you wish to give the resource you are creating. Another parameter you can specify in this section is label. So what is label? You would agree that the essence of labeling is to be able to identify the attributes of an object based on the labels on the object. For example, if you have 10 pods in your cluster, depending on the job function each pod does, you can choose to group them by labels. So for instance, let's say pod A, B, and C are the front-end applications. You can choose to label them by these attributes so that anytime you query pods that are front-end applications, you will get pod A, B, and C. So labels are part of the metadata section of a Kubernetes or OpenShift resource that can be assigned to an object or a resource based on their attributes. So you can add labels to your ports, deployment, service, and some other Kubernetes resources. So under labels, for this pod, we can specify a label key as app, and we can also use a value called Nginx. So if I wish, I can also specify another label as environ and use a value of production. If I want to specify a label name, I can also do that. You can specify as many labels as you want. It just depends on how you want to group your resources. Before I continue, let me quickly show you one of the easy way to create your own YAML configuration file using the Kubernetes website. So when you go to kubernetes.io, so from here you can go to documentation, I think. Then from documentation, let's see. Okay, let's go to reference. From reference, let's go to Kubernetes API workload resources. So you can see pod. I can just right click and open pod here. For deployment, I can open it in another tab. And for service, since we are dealing with these three resources, so I'm just going to open for pod, deployment, and service. And now you can see here that pod is blah, blah, blah. You can see the API version, which is V1. Like I said, they're divided into 5 parts. The API version, the kind, the metadata, the spec, and status. So for API version, you can see that for pod is V1, the kind is pod. If you want to see more information about the metadata, you can click here to see. The same thing goes for deployment, and the same thing goes for service as well, right? So for deployment, for example, let me just open more information about the metadata here. You can see that in metadata, you can have the name, and it is telling you that the name must be unique with a namespace, blah blah blah. The namespace, the labels, you know. So when you go through all of these, you will see that with the Kubernetes website, you can easily create a YAML configuration file. It is very simple to create. Even if you click here, this port spec, you can see that for port spec, you need to put the parameter containers, and it's saying that the parameter containers is required. And here too, the name string is required. So whenever you say required, it means that you must put in that parameter. Wherever, if you don't say required, it means that you might not really need that parameter. If you don't want to use it, you might not put it, but when you say required, it means that the parameter is required. So meaning that the name of a container is required. Having said that, the fourth part of the configuration file is specification, shortened as spec. You know, when you see a guy or a girl that meets your criteria, you say something like, wow, this is my spec. Now that's simply specification. Yeah, that's simply specification. So this part of the configuration file will contain the specification of the desired behavior of the resource you are creating. So for pod spec, you can have parameters like containers, and in the container section, you can you can have list of items such as the container name, the image, the port, and etc. If you check the Kubernetes site, you will see that the container name is required. You will also specify the container image. So because I did not specify a tag, I will definitely have the latest version of the Nginx being pulled. Like I have mentioned, you need to have the basic knowledge of container runtime, such as Docker, Podman, Containerd, or whatsoever container runtime before studying this course, so you will understand the structure of container images and other basic things. I'll be dropping the link to my Docker and Podman course in the description box below if you're interested and if you do not have the basic knowledge of how container works. So another parameter in this section can be the container port. And you can also have another list of items here. So we can have container port to be 8080, and because you can have more than one container in a pod, if you wish, you can also add the other container information just like this. But because I only want one container in this pod, I'm going to remove this part and make sure that I have just this information for this container. And also for deployment spec, don't forget this is we're talking about the pod spec. And for deployment spec, you can have parameters like replicas. You can also have parameters like templates. So what is a template? A template is the pod specification. So in this section, in the template section, you will specify the pod template specification. Don't forget that deployment manages pods, so you need to specify the container or pod specs in the deployment too. And this will be done in the template section. In the template section, you can have parameters like metadata, spec, and etc. It's just like, putting the metadata part of the spec part of the pod inside the template section of the deployment configuration file. After all, the deployment manages the pod, so there should be a pod configuration file in the deployment as well. And we can also have parameters like selector in the spec section. So what is selector? Selector work hand in hand with labels to establish connections among other Kubernetes resources. There is a tight handshake between these two resources, label and selector, and label and selector work hand in hand to connect pods and deployment together. Label and selector also work hand in hand to connect services and deployment, and among other resource connections. So for deployment, a required parameter in the selector section is the match labels. This is actually a label selector. So this will match the label here in the pod section so that there can be a connection between the deployment and the pod. So you need to watch out for the key value pair you use in this label and selector section, because if you do not make sure that this label matches, you're going to be having issues because there won't be a connection between the two resources. And for the service component, we can have the selector parameter. Like I mentioned that label and selector work hand in hand. So the selector here, which is the app equals Nginx, will be used to connect this service to the deployment or pod as the case may be. This is how the service finds pods to forward packets to. In the spec section, we can also have the port parameter. We can specify the name of the port and the port you would like the app to be exposed to, including the target port, that is the port the app uses, and you can also specify the type of service. So in this case, the type of service, of course, is node port. If you want it to be load balancer, you specify load balancer, and if you want it to be cluster IP, you specify it to be cluster IP. And the last part of the YAML configuration file is status. You can see that for now we cannot see status here, and that's because the status part is automatically generated by Kubernetes, and it will be added automatically by Kubernetes when the resources has been created. So having understood this, let us apply this YAML configuration file one by one. We will start with pod. We would apply pod, and after which we apply deployment and service. So let's go practical. Before we start to apply these YAML files, let me open one of the components. Let's open the deployment file. So I'm just going to say vi deploy to.yaml. So here you can see the types, the part of the configuration file. So you can see that the first one here is API version, the second one here is kind, the third one is metadata, the fourth one is spec, and like I said, the fifth one, which is status, is always automatically generated. So you can, I just want to quickly explain the indentations. So you can see that for the main part, like I said, YAML is the parent-child relationship. So let me move this here. So for the main part, which is the API version, you can see that they all start from the same line. That is the API version, the kind, the metadata, the spec. So let me just push this here. You can see that they are all starting from the same line, and that's because they are parents when it comes to indentation. And for the API version, the value is apps/v1 here. For kind, the value is deployment. And for metadata, because we can have various values, we can have various parameters under metadata. So those parameters are going to become the children to the parent, which is metadata, and that is why they will never start from the same line as metadata. So you can see that name did not start from the same line as metadata. Because it is a child to metadata, it's going to have, some spacings, and then it's going to start from this side, and then you can have the name, you can have the value of the name to be Nginx application. And also under metadata, we also have a parameter which is labels, and because we can also have different, numerous labels, this label, this is one of labels, it becomes a child to the parent label. And don't forget that even labels is a child to the parent, which is metadata. So that is indentation, which really matters. It's very simple to grasp. When you can understand the parent-child relationship, the indentation in YAML, then you're good to go. So you can look at the spec here too. You can see that for spec, we have different values. So we have the replicas here, and we have the key to be 2. Under spec, we have templates. These are children to the parent, which is spec. And if you come down also, you can also see that even selector here is not starting with spec because it is a child to the parent spec. So this is all about YAML. This is all about child-parent relationship. If you've gone through my Ansible course, we also did this. We explained this too. And what I did to be able to edit my VI so that I can be able to get the right indentation, which is this line, is that I made some settings. I'm going to be dropping the link in the description box below on how I made those settings. And also, if you don't want to use the VI, you can use your VS Code. And even as a matter of fact, you can have your Kubernetes extension being included in your VS Code. Maybe one of these days I'm just going to do a lesson on that. When you have that extension being included in your VS Code, you can easily create any Kubernetes resources and you have the templates in there and you can easily write on those templates. So having understood this, you should also know that you can make use of YAML validator. So there are a lot of YAML validators online just to be able to see if you've rightly written this configuration file. So this is all about it. So having understood this, let's see how we can apply this component. So I'm going to start with applying that of the port first. So here on the system, I have some YAML port configuration file, but let's look at port 2.yaml. So we can see that here we have the API version to be v1, kind is port, metadata, I have the name and labels, and I also have the spec section here. And we're going to be creating a container with the name Nginx, and we're going to be using the Nginx image. And the port we have here is port 8080. So I can create a pod with this YAML configuration file or manifest file. And to do that, I can just say OC create file pod2.yaml. So you can see that the pod Nginx has been created. And to confirm that, I can just say OC get pods. You can see that the container is still creating. And if I wish, I can just watch this process. So it's already running and I can just say OC get pods again. So you can see that the container is running. And if I also want to delete this container, I can also use the OC create file. So instead of saying OC create, I can just say OC delete file for 2.yaml. You can see that the container Nginx app has been deleted. And if I say OC get pods, you can see that I can't find the container here any longer. So this is how you use the YAML manifest file to create resources in OpenShift. You can see how easy it is. You can see how you can easily, edit the YAML file if you want to quickly, work with a lot of clusters. So this is why it's one of the reasons why it's better to always use the declarative approach. So let us also create the deployment. So if you look at this deployment file, I can say vi deploy to the YAML. You can see that the API version is apps/v1 kind deployment metadata. We have the name, we have the label, we have the spec, replicas equals 3. So we're going to be creating the 3. We're going to be creating rather 3 replicas of this Nginx pod. And you can see the container here. And we also have the selector here too as well. So I can say OC create file deploy to.yaml. You can see that the deployment has been created. So if I say OC get deployment, you can see here that it's not yet ready. We still have 0/3. If I say OC get deployment again, We still have 0/3. If I say also get pods, we should see container creating. So they are still creating, so I can just use the watch option here. You can see now that the containers are running. So if I say also get pods, you can see that we have 3 replicas of this pod running. And like I said, if you also want to delete this, I can just say OC delete deployment. OC delete the name of the YAML manifest file. So you can see that this deployment has been deleted. And if I say OC get pod, they are already terminating. If I say OC get deployment, I don't have any deployment here any longer. And if I say OC get pods, they are still terminating. So I can just use the watch command until they are fully terminated. And I can say OC get pods now. So you can see that we don't have any pod in this namespace any longer. And for the service component as well, if I say I have service2.yaml, and you can see, of course, the API version is v1 kind, the service metadata, we have the name of the service, we have labels, we have spec, we have selector here, we have port, and we have the type of service, which is node port. So to create the service, of course, I can say again, OC create file service to the YAML. So you can see that the service has been created. So if I say OC get service, you can see that I have the service here being created. And one good thing is, let me just delete the service first. And the next, oops. We can as well, just use the delete OC delete option here. You can see that the service has been deleted. So one good thing I can do is, so let's say cat service to the YAML. I can just copy this. Let me just copy this and oops. So copy and vi deploy to the YAML. So here I can have another YAML manifest file being embedded in one YAML manifest file. So most of the time, you can always have the deployment and the service, you can always have them together in one YAML manifest file. So I can just paste it here. Just say paste. So that's been pasted and I can save this file. So now if I do OC create file deploy to the YAML, so you can see that we have 2 components being created, one which is the deployment being created, and the other one is the service as well that is being created. And if I say also get deployment, you can see the deployment, and if I say also get service, you can also see the service as well. So thank you for watching, and in the next class I'll briefly talk more about label and selector. So I'll see you in the next lesson. Thank you once more for watching. Please don't forget to subscribe, like, share, and comment. When you do this, you will encourage us to do more. Bye for now. Hi everyone, Victor here again, and in today's lesson, we're going to be deploying our first mini project. And I wanted to do this topic later on, but because I need to explain some other concepts, some other Kubernetes, OpenShift objects and resources, hence we're going to learn this object by deploying this mini project. And this mini project is simply the deployment of 2-tier applications, which are the MySQL database server and PHP My Admin. I chose to deploy these two applications because I remember those years. Those years I usually do web design with content management system, WordPress to be precise, so I could get some cash to survive. I'll just go to the control panel and then open the PHP My Admin application to manage my SQL database for some website I designed those years. And it's actually interesting, so that's why I chose to deploy these two applications. All right. So in this lesson, we're going to learn the following. We're going to learn how to deploy multi-containers application, which of course we have the MySQL and PHP and we're also going to learn how to deploy secret, how to create secret. We're going to also learn how to create config map. In this project, I'm going to be acting as the Scrum Master and the product owner. I'm just kidding. So here's the plan. We're going to deploy my SQL database server first. And because we don't want to expose our database to the outside world, we are going to create an internal service for MySQL, after which we will deploy PHP front-end application that we're going to use to manage MySQL. And since PHP is front-end and we need to interact with it from the browser, we're going to create an external service for PHP However, PHP and MySQL will communicate with each other by using the internal service that has been created for MySQL, and then we will create a database from PHP to test the deployment. In all of these, you will learn what secret and config map are and how to use them. So let's start with understanding what secret and config map are. These two objects or resources are similar to each other, but first, let's look at what secret is. Secret, from its word, is simply secret. Okay, the secret object, from its word, basically holds secret or sensitive information that you don't want to expose to everyone, or rather the cluster users. The secret information could be usernames, passwords, SSH keys, or sensitive configuration file, etc. So the way it works is that the secret resources is going to be created separately, either by using the command line or YAML. Then the application pod or any other resource can reference the secret, which basically means that what needs to be referenced needs to be created first. In other words, the secret which is going to be referenced by other resources needs to be created first before creating other resources. So let's say you have applications like MongoDB, MySQL, or even some other applications that needs to be deployed with sensitive information such as the SSH keys, sensitive configuration files, usernames, passwords. The ideal thing is that this information are protected. So what you would do is to create a secret and put this sensitive information in the secret, then reference or point the applications to the secret. The application pod or other resources can reference the secret basically in two ways. One way is to add the secret as environment variables, for example, in the application pod, and the other way is to add it as a volume inside of the pod. So let's see how this can be done while we're deploying our mini project. So according to our design, the first thing we're going to create is the MySQL application pod. And to do that, we can run the command create deployment MySQL. That's the name of the deployment, and I'm going to be pulling the MySQL image. So you can see that the deployment has been created. I'm just going to ignore this warning sign. It's about security context. So if I do also get ports, you can see that we have an error. The status is error. And if I do also get ports again, you can see that the container is running. And if I do also get ports again, you can see that we have error. And if I do also get ports again, you can see that we have the crash loop back of status. And if I do also get ports again, you can see that the container is running again. And if I do also get ports again, you can see that we have error. So this container would not start, and you just keep having error, crash loop back of status running, and all of that. And the $1 million question is, why is it that this container would not start? And my friends, to answer your $1 million question, you see, you don't just deploy some application pods without environment variables, and my SQL happen to fall in that category. You can't just create some database pods without adding the necessary environment variables. So let's see how my SQL container can be used. If I go to hub.docker.com, so this is the official website for Docker, and I can search for the MySQL container. So you can see the Docker official image for MySQL. So I can just click here, and here you can see how you can use the Docker tool to pull MySQL container. And you can also see other information about this container. You can see here saying what is MySQL. MySQL is what's most popular, blah, blah, blah. Well, what I'm concerned about here is the environment variable. So I can just do Control F and search for environment variables. And you can see the environment variables section here, and you can see the different environment variables that we have. So one of which is the my SQL underscore root underscore password, and you can see that this variable is mandatory, and this variable will specify the password that will be used for my SQL root super user account. Well, I mean, it is important, because how would you even create my SQL server without creating a password for the root account? So that's why this variable is mandatory. And we also have some other optional variables. You can see this my SQL underscore database. You can see that this variable is optional, and what this variable would do is that it would create a database upon the creation of the MySQL server. And also we have the MySQL underscore user and MySQL underscore password variable. These variables too are optional. And what this would do is that it will create an extra user, and it will also create the password for that extra user that will be able to log in to the MySQL server. So we have some other variables, but let's just stop here. So let's create this pod again. And this time around, I will be using the YAML manifest file, which I already have. So I have it in my SQL deploy.yaml. So if you look at this YAML manifest file, you would understand if you've been following us through this course. And of course, it follows the same convention, which is the API version, which is the app/v1. The kind is deployment. The metadata, that's the name of the deployment. And what we're concerned about here is the environment variable section, which is here. You can see the environment variable section, and you can see that the first name of the environment variable is the MySQL underscore root underscore password. which is the mandatory variable, and the value for this password is, so what I'm saying is that this is the password, and the second environment variable that we have in this file is my SQL underscore database, and this is the name of the database. And the third environment variable rather that we have is my SQL underscore user, and this is the user for that environment variable. So we can now create this file. Okay, we also have another one, which is the MySQL underscore password, which is the password for this user, DB user. So let's create this file. Let's create this pod using this file. And also, I'll be dropping the link to this course in the description box below. So in case you want to copy the file, you don't need to type and paste. You know, you don't need to type rather, just copy and paste so that you can easily use it in your lab. So to create this file, I can just do oc create file SQL deploy YML. All right, we have a warning and we have an error which says already exists. So let me just delete the former um, deployment. Let's also delete deployment SQL. If I do also get ports, so we don't have that deployment there anymore. So if I create this, so you can see that we have it here that the deployment has been created. And like I said, I'm going to ignore this warning. So I can just say also get ports again. You can now see that my SQL is running. Let's confirm that again. If I do also get ports, you can see that my SQL keeps running. If I do also get ports, it keeps running, and 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 it will forever continue to run. Going forward, if you look at this YAML manifest file again, which is my SQL deploy.yml. So let me just cut this file. You would see that we have sensitive information being exposed, which is the my SQL root underscore password. You can also see that these passwords are being exposed, and this is a sensitive information. And you and I would agree that it is not ideal to expose sensitive information such as this in a YAML manifest file. We learned this during our Ansible course too as well. You might want to give this file to your colleague to review, or you might even want to, give a support engineer to review this file. And trust me, exposing this kind of information is not recommended. Hence, the need for secret. And I explained what secret is, and I said that secret in Kubernetes object is used to protect or store a sensitive information. So hence we're going to be creating a secret so that we can store this sensitive information in them. In it, I mean. So before we create a secret, let's even look at the types of secrets that we have. If you look at the Kubernetes website, let's look at the types of secrets that we have. You can see that we have the opaque secret, we have the service account token, we have these are the types of secret that we have. We have the basic auth, but the most commonly used secret is the opaque secret, the basic auth secret, and the SSH auth secret. So in this case, in our own scenario, we're going to be using the opaque type of secret. So let's create our secret. And we can also use the YAML manifest file to do that, which I already have too as well. So if I just open this file and if I do vi my SQL, the file is my SQL secret.yaml, you can see that here we have the API version, which is v1, and the kind is secret, and the metadata, which is the name of the secret, is my SQL-secret, and the secret type, like I said, we're going to be using the opaque type of secret, and this is the data in the secret. So if you look at this data, the first data is my SQL-root-p. So I'm just saying that this is my SQL root password, and you can see that it's been encrypted. And this is my SQL username. You can see that this is also being encrypted. And you can see my SQL password, and you can see that this is also being encrypted. So this is being encrypted with base 64 type of encryption. So let me quickly show you how you can encrypt, encrypt a sensitive information, be it password or anything with base 64. So to do that, you can just simply use the echo command. So you can say echo, I can say echo dash n, and so for the password, I used password that's PA55WORD, and this is going to be piped to base 64. Base 64 is together. So you can see the password here. And for the other user, I used DB user one. DB user one. You can see the value here too. So if I do cut, my SQL secret, so you can see that it's the same. You can see the password. You can see that this corresponds to this. And for the username, which is dbuser1, you can see that this corresponds to this. So this is how you're going to encrypt sensitive information with base 64 encryption. So now we can create the secret. So to create the secret, I can just say secret file. You can see that the secret has been created. And so if I do oc get secret, you can see that the secret is my SQL-secret, and it is the opaque type of secret. So now that this secret has been created, we need to reference the secret from the YAML manifest file of the pod. So to do that, we need to, of course, recreate that YAML manifest file. And the good thing is that I already have a file that is being recreated, and I have it to be in it's in my SQL deploy dash secret, yeah, .yml, and this is the new file. And if you look at this file, of course, it will follow the same convention. Let me just cut this file instead and just do more. If you look at this file, you can see that it's following the same convention. We have the API version, which is apps/v1 kind deployment, blah blah blah. And when you get to the environment variable, so this is how you can reference a secret. So after the environment variable, you're going to be having the name of the environment variable, which is my SQL underscore root underscore password. And this is going to be value from, and you're going to be referencing the secret. So that's why you're going to be having secret key ref, and followed by the name of the secret, which is my SQL-secret, and then followed by the key. Don't forget that this key is what we created in the secret to reference what we encrypted. Like I said, don't forget that this key is what we ourselves created to reference the encrypted sensitive information. So if you come to the secret here, where's the secret here again? So you can see what we created. We just give it this name. So we want it, we don't want, as a matter of fact, we don't even want the encrypted information to show. That's why we gave it this name so that it can reference all of these secret information. And when you come back here, if you look at this environment variable as well, which is my SQL underscore user, right? You can also see that it will also follow the same convention, which is value from secret keyref, the name of the secret, and the key, which is my SQL username. Also, with this third variable, you can see that value from secret keyref, the name of the secret, and this is the key, my SQL password, just like we give it here. Can you see them here? So this is how you're going to reference a secret from the YAML manifest file from the pod section. So now we can recreate this file. And so if I do also get pods, I'm just going to delete this one which is running. So to do that, I can just say also delete. Oops, and delete this. So, oops, what did I just do? Let's see. Oh, sorry guys. Sorry guys. What's to create secret? So I'm going to delete. I'm going to delete this. Deploy my SQL deploy that secret.yml. Let me be sure. This is what I'm going to delete. Oops, what am I doing? Sorry guys. I think I need to. I just keep deleting the secret. I think it's my SQL deploy.yml. If I can't get that file again, I'll just delete this. I can just say OC delete pod. I think it's OC get deployment. Let me just delete the deployment. OC delete deployment SQL. If I do OC get pods. Alright, so let's create this again. Let's create the my SQL server again. So I can just do OC create file this. You can see that the deployment has been created, and now if I do OC get pods, container is creating OC get pods. You can see that my SQL server is running, and if I do OC get pods again, you can see that it keeps running, and this will keep running forever till you stop it. So now you can see that this is the right way to create a pod that has sensitive information. First, you need to create a secret, and then you can reference that secret. So the next thing we're going to do, according to our design, is to create an internal service for my SQL. And of course, you already know how to do that because we've done that in one of our previous lessons. And of course, we can also use a YAML manifest file to create the internal service. And I have that already, which is in, so let me just cut that file. The file is my SQL service.yml. So this file would create an internal service for my SQL server, and of course you can see API version, kind, service, metadata, the name of the service, spec selector, app, MySQL. So to create this, of course, you can just do create file. So you can see that the service, my SQL has been created. And so if I do what's it get service, so I'm trying to look for the service, my SQL service has just been created. So you can see the service here. You can see that the service has been created. So the next thing we're going to do, according to the design, is to deploy PHP my admin application. So let's even look at how this PHP my admin application can be deployed. If you check if you check up.docker.com again, and this time around I'm going to search for PHP my admin. So this is the Docker official image. So I'm going to click here. And of course, you can see how you can pull the image using the Docker tool. You can see the quick reference. You can see what PHP is. PHP is a free software tool written in PHP, blah, blah, blah. So what I'm concerned about here is also the environment variables. So I can just search for environment variables here. And we have different. Okay, so I can check the environment variable summary because I'm seeing some other stuff there, but let me just check the summary. And here in the summary, you can see, so this is the variable I want to point out to, which is PMA underscore host, which defines the address or host name of the MySQL server. And we've already created that host name. Don't forget that that host name or the address is the internal service that we created for my SQL server. So another important variable, of course, which I want to show to you is the MySQL underscore root underscore password. So you see that this variable is mandatory, right? And it will specify the password that we use to set for the root super user account. So don't forget that we've actually specified this password. So these two variables, which is this and this, are going to be used to connect to our MySQL server from the PHP MyAdmin application. Moving forward, let's create the PHP MyAdmin application pod. And of course, as usual, I also already have the YAML manifest file for this PHP admin. So if I just cut the file, I can say PHP admin deploy.yml. So if you look at this file, and you can see the API version, kind, deployment, metadata, spec, and if you come to the spec here, that's the spec for the container. And if you check the environment variable here, you can see that the name for this environment variable, which is my SQL underscore root underscore password, which is mandatory. You can also see the value, which is also what we created the other time. And that's when we were creating environment variable for my SQL in that YAML manifest file. And also you can look at the name here too. And like I said, the PMA underscore host here, it's actually talking to the internal service, which is also my SQL. Don't forget that the name of the internal service that we created is my SQL. And just like I have said before, I said that it is not recommended to display sensitive information such as this in a YAML manifest file. So what we're going to do first is that we're going to remove this. And since we already have it in the secret that we created, so we're going to just reference it in that secret. And for this other one, for this other value, this is going to lead us to what config map is. So we're going to create a config map and we're going to put this inside of the config map. So the config map, is similar to the secret object. The only difference is that the secret object is used to store sensitive information, while the config map is used to store a non-sensitive information. And the idea is that we're going to put this in a config map. So it's going to just be like a centralized place whereby other applications or other objects that want to use this value can reference that config map. So if it's here, there's no way other object that wants to use this value will be able to reference this. So, but when we centralize it and we put it in a config map, object A can reference it, object B, object C, object D. All right. So it's just a way of putting um, an information in a central way so that other objects can also reference it. So what we're going to do is that we're going to recreate this now. And before we do that, so first of all, I'm going to create a config map. And to do that, I also have a YAML manifest file for config map. And the file is in, so the file is here, that's cat sql dash config map.yaml. So you can see the config map here. You can see that it's taking the same approach, the same convention so, as secrets own. API version v1 kind is going to be config map. Metadata, which is the name of the config map data. And config map does not have a type, and that's why you're just seeing only data A. And you can see that this is the data we have in this config map. So this is just going to be referencing, this is just going to be referencing this inside of the config map. So now let's create this config map. So if I say, let's see, create file mysql config map.yml. So the config map has been created. So if I say oc get config map, you can see that the config map has been created, which is mysql config map. So what we're going to do next is to, like I said, we need to recreate this. We need this to be able to reference, these variables to be able to reference both the secret and the config map. And again, I have a YAML manifest file for that, which is in the file is in PHP. So let me just cut the file, cut PHP admin deploy dash secret.yml. So this is the file. If you look at this file, you can see that the API version is apps v1 kind deployment. And of course, we're coming to the environment variable here. And in the environment variable, you can see the name of this environment variable, and you can see value from, and you can see here secret key ref. We're going to be referencing this name here. That's the name of the secret, and this is the key. So we don't have issues with this because we did this before. And of course, we don't even have issues with this. So it's going to follow the same approach. The name of the environment variable, this is going to be value from. So instead of the secret key ref, this is just going to be config map key ref. And then we're going to be having the name of the config map. And then we're going to be having the key. So it's just as simple as this. So we can now create this PHP my admin application. So I can just say create file. So you can see that this has been deployed, it's been created. So if I say get pods, so the container is still creating, that's for PHP my admin. And if I say get pods again, it's still creating. So let me just see what is happening. Describe pod. All right, so we are at the stage whereby the image is being pulled, and that's why it's not running yet. If I do also get ports again, the container is still creating. So I'm just going to put this at the watch command till we allow the container finish creating. So I'll probably, I think my internet is a little bit slow. So I'll probably just pause, and when it's been created, I'll play again. All right, so this is been created, and you can now see that the container is running. So if I do also get port, we can see now that the container is running. And according to our design, the next object that we're going to be creating is the external service for PHP my admin, and I have that too as a YAML manifest file, which is in PHP my admin service.yml. And if you look at this, you can see, API version, kind, service, metadata, PHP my admin, that's the name of the service, and the type is node port, meaning that it's an external service, right? And so if I do OC get port, OC create rather, uh, so now if I do OC get port, you can see the two ports running. OC get secret, you can see the secrets that we created. OC get config map, and also see the config map that we created. And if I say OC get service, you can see the services. I'm seeing my SQL service, and I'm seeing PHP my admin service. So you can see the services that we created too as well. So now that we are done with this deployment, let's test our configuration. So I'm just going to go to the browser. So from the browser, I can just clear the screen. So this is let me make this bigger. So I can just get the IP of the CRC node. So I can say CRC IP. So you can see the IP of the CRC node here. So let's say OC gets service. So I'm on the, I was using putty before, so I'm on the console itself. So if I do OC get service now, you can see this service here. So I'm going to copy this IP here. I'm also going to use this port, which is 30588. So let me open Firefox. So I'm just going to paste here 30588. So let's see if this is going to open. All right, I can see that it's beginning to open. I just hope that my screen recorder is catching this. So let me just quickly confirm that. All right, so my screen recorder is catching this. So what I'm going to do next is to log in. So we're going to log in as the root user, and the password, of course, we set PA55WORD, if I'm correct. So I just say don't save. I'm going to log in. All right, so you can see that we are now able to log in using our front end application, which is the phpMyAdmin, into the database server. And for us to, of course, for us to confirm, you can see the database MySQL that we created. You can see the MySQL database that we created. And for us to do this confirmation again, if I go to let me go back here. Okay, if I go to user account here, so you can see the user extra user that we created, which is the DB user one. So this shows that this deployment is working fine. And also, let me quickly show you something because this is OpenShift, right? I can actually also create a route. So I can say OC expose service. We're going to be exposing the PHP, my admin service. So if I say OC get route, so you can see the route here. So I can just copy this and I can open this again and let's paste this here. Oops, let's try this again. Hey, come on, I'm not saying you should open this with Google, man. Let's try this one more time. So this should work, and I don't know why this. Okay, I think this is it here. Yeah, HTTP. All right. So this should work because this is a route. This should work. Okay, so this is working. So meaning that we can also log in via the route. So I can see that it's about to open here. So this is also working. So this is fine. I'm also going to be dropping our course, the Kubernetes course that is related to this in the description box below. It's similar. It's almost like the same thing. We did some series of tests at the end of at the end of that lesson. So if you wish, you can also check. What we did was we created a database um, from the from the CLI command and checked here at the GUI. We also did the same thing from the GUI and we checked the CLI too. So I want to say thank you for watching and please don't forget to subscribe. You see, I had to make this video again because I had issues with my recorder, and just because I wanted to come out clearer, I had to make this video again after I've made it before. So what you can just do to help us is to please subscribe, comment, guys, comment, share, like, and when you do this, you encourage us to do more. And thanks for watching, and bye for now. Hi everyone, Victor here again, and I welcome you to this lesson, which is creating and managing storage in Kubernetes and OpenShift. In this lesson, you will learn about some Kubernetes and OpenShift components such as persistent volume, persistent volume claim, and storage class. If you're familiar with virtualization technology for enterprise environment, you would understand that the ideal or proper thing to do when configuring storage is to use external storage, be it in the form of SAN, NAS, or NFS, or whatsoever external storage to store your data for persistency, consistency, and for high availability instead of using the local storage where your VM resides. And this same thing is applicable in Kubernetes and OpenShift. So let's look at the following scenarios. When you have pods of the same replicas distributed across different nodes, and the container app or pod is the one which needs to consistently talk to storage, either to write or retrieve data consistently. For example, databases. Having the pod to talk to a local storage will definitely cause data inconsistency because the pod because the pod in node A talks to the local storage in node A, while the pod in node B talks will talk to the local storage in node B, and the same is applicable to node C. How is it even possible for the database application to be sane or have the latest or correct data? Hence, the ideal practice is that the pod talks to an external or centralized storage. And even more so, like I've mentioned in one of our previous lessons, that pods are ephemeral in nature, meaning that a pod can easily die, and when they die, they are automatically recreated. So, say a pod which resides in node A dies and is automatically recreated in node B, how will the pod connect back to the local storage in node A? But if the pod is independent of the local storage, as soon as the pod comes back up on any node, it can easily connect back to the external storage, making data to be consistent and persistent. Therefore, for you not to have data corruption or data loss, using an external storage is the way to go in this case. This is not even only applicable to databases, it is also applicable to applications that need to read data from some sort of files or storage. For example, if you have apps that depend on each other, say two-tier apps, front end and back end, and it is configured to access data through a directory or some sort of files. To have data consistency, the way to go is to make use of an external storage. However, you may still configure your app to use a local storage as well as an external storage. It all depends on the way you want your application to function and how you want your environment to be. Just like in virtualization, where the whole cluster can crash, or where you would need to even tear down the whole cluster, the same can happen in containerization. So if the whole cluster goes down because your data or storage is independent of the cluster, your data is safe. So in summary, what we have been discussing are you can have a local storage or volume or a remote or centralized storage or volume. The local storage can be ideal in few cases, while the remote storage is ideal in many cases, just like the scenario we have stated. So, we want a storage that is independent of the whole cluster and, of course, separated from the pod life cycle so it can be persistent and available on all nodes. So, how are these PVs, persistent volumes, persistent volume claim, and storage class related to storage? Basically, there are two cluster users. We have the cluster administrator and the developer or application owner. And the job of the cluster admin is to provision a storage or volume and of course a persistent one, hence persistent volume. Persistent volume is the storage itself, and of course, storage can be a local hard drive, storage server, storage box, be it Dell, HP, Synology, and be it in form of any protocol, say NAS, SAN, NFS, or even cloud storage. And just like you would normally create a volume and map it to a server with your IQN for DAS or iSCSI or WWN for FC, you would also need to create a resource called persistent volume using the YAML and specify the storage parameters, that is the volume size, the protocol, the storage IP, the volume mode, either read write or read only, etc. And you should also know that persistent volume is not restricted to a particular namespace. It is available to the entire cluster. And we will look at how to do this, how to create persistent volume as we go on in this course. Going forward, when the persistent volume has been created by the admin, the developer can now claim the persistent volume, hence persistent volume claim. So the developer needs to create a persistent volume claim resource and specify the parameters using the YAML also. So for example, there can be a large pool of persistent volume, say 500 gigabyte. One can claim in chunks per application. So one can claim 200 gigabytes for pod A and another 200 gigabytes for pod B, or even claim the whole volume. It just depends on how you want the setup to be. And PVC is restricted to a namespace, unlike persistent volume. We would also look at how to create a persistent volume claim as we go on in this course. And finally, we can also dynamically provision or create a persistent volume, and that's where storage class comes in. Imagine a scenario where we have large environment and we have hundreds of pods running, and these pods need volumes. So instead of manually creating persistent volumes or contacting the cluster administrator to always create persistent volumes, one can dynamically create these persistent volumes by using storage class. So when you create a persistent volume claim, a persistent volume will dynamically or automatically be created for you. And this can be done, like I said, with the aid of storage class and with a specific provisioner. The storage class can also be created using a YAML manifest. We can also specify the provisioner in the storage class YAML config file or manifest. We will look at how to do this too as we go on in this course. So I just want you to have an understanding of storage in Kubernetes and OpenShift. And having understood all of this, we would see how to do this step by step. In the next lesson, we'll look at how to create a persistent volume claim, and storage class. So thank you for watching, and please don't forget to subscribe to this channel. Share, like, comment, and subscribe. When you do this, it will encourage us to do more. And thanks for watching once again. Bye for now. Hi everyone, Victor here again, and in today's lesson, we'll look at how to create persistent volume and persistent volume claim and attach it to a pod. We will learn how to create storage class in subsequent lessons. In the previous lesson, I explained the storage concept and I mentioned that a pod can either be attached to the local storage or a remote or shared storage. In this lesson, we'll be attaching the pod we'll be creating to a shared or remote storage. And since I don't have any physical storage array, like the likes of Dell, HP, IBM, etc., I'll be making use of another server as my remote storage and then configure NFS on the server so that the server will serve as a remote or shared storage. So without further ado, let's get started. So this is my remote storage here, which is going to be my NFS server. And if you look at the IP, you will see that it has an IP of 192.168.37.128. And this is a Red Hat Enterprise Linux 8 server. So we're going to be configuring NFS on this system. And this same step is also applicable to a Red Hat Enterprise Linux 9 system, RHEL 7 systems, CentOS 7, CentOS 8 systems. So I already have the NFS configured on this system, but I will just show you what I did. So to configure NFS on a RHEL 8 system, the first thing you need to do, of course, is to install the NFS utils. And to do that, you can just say yum install NFS utils. And because I already have this utility installed, it will tell me that it is already installed and there is nothing to do here. And when you're done installing, what you need to do is to start the RPC bind service. And to do that, you can just say systemctl start RPC bind service. And you can check the status of the service. So you can just say status. So you can see that it is started and running. And the next thing we can do is to start the NFS server as well. So I can just say systemctl start NFS server. And I can also check the status of the NFS server. So you can see that NFS server is loaded, it started, and it's running. So the next thing I'm going to do is to create the NFS shared directory. And to do that, I can just say make directory. So we're going to be sharing the directory NFS share. So I already have it created, so it should tell me that it already exists. And now I can export the share. So to export the shared directory, I need to edit the etc export file. So I can just say vi etc export. So you can see the third line here, which means we're going to be exporting this share, which is NFS share. And I have it here that I'm going to be exporting into all system, that is to the whole world. And I have some options here: read, write, sync, no sub tree check, no root squash, no all squash, and insecure. So I can save this file. And when I'm done saving this file, if you have firewall on your system, you need to add the NFS firewall rules to your system. But in this case, I'm going to be disabling firewall. And to do that, I can start RPC bind again. So I can say systemctl restart RPC bind, and I can say restart NFS server as well. So I can disable firewall D, so I can say stop firewall D. So if I say status firewall D, so I can just say status here. You can see that firewall D is stopped. But if you don't want to stop your firewall, like I said, just add the NFS rules the NFS services and ports to the firewall rules. I'll be dropping the link to this specific NFS provisioning that I have done before in the description section below, so you can see what I have here, NFS rules and all of that. So if you want to check how to configure NFS, so you can just click on this link, right? So let's go on. So we can now export the shares. So I can just say export FS A. I can add variables and I can even say re-export if I wish. So you can see that I'm going to be exporting the NFS share directory, and I can also confirm by saying show mount. So you can say show mount -e localhost. So you can see that we're going to be exporting this to the entire world. So this is how you would configure your NFS server. So like I have said, this server is acting like our remote storage, right? So if I already did this, like I told you, so if I do df-h, you can see that the NFS share directory is mounted on a disk itself. So it's mounted on dev SD1 disk, and it has a size of 13 gigs. So this is our remote storage in this case. And since this is our remote storage, of course, you should know that Kubernetes would not manage your storage for you. You will be the one to manage your storage by yourself, to do your backups, to do all the management as regards your remote storage. So now that we've done this, we need to go back to our cluster environment. So now I am on the OpenShift cluster server. And what we're going to do on the NFS client side is also to install the NFS utils. And to do that, I can just say dnf install NFS utils. So you can say yes to all options. This command needs to be run as a root user. So this is going to install the NFS utils for us. So I'm just going to pause the video, and when the installation is done, I'm going to resume the video. So now I can start the RPC bind service. So I can just say sudo systemctl start RPC bind. So I can verify that it's been started. So you can see that the service is active and it's running. So now let's verify that the NFS shared directory is available on our cluster node. And to do that, I can just say show mount -e followed by the NFS server IP, which is 192.168.37.128. So you can see that the share is available, and the share is NFS share, just as we created it on the NFS server. And this is being shared to the whole world. And now that we've been able to verify this, let's try to mount it to the shared directory. So I'm going to just mount this to /mnt, just for me to be able to be sure that I can mount this directory. So I can just say sudo mount. This is going to be -t nfs 192.168.37/128. Then this is going to be /nfs share. Let me mount this to /mnt. Alright, so I can confirm that this has been mounted. So I can just do df-h. So you can see that this has been mounted. You can see the share here. So this is good. We've been able to verify that we can reach our shared storage, which is the NFS server. So now I'm just going to unmount this. So I can just say umount /mnt. Oops. Just say sudo bang bang. So if I do df-h, so this has also been unmounted. All right. So we have our shared storage available, and we also have our cluster node. This is the OpenShift cluster available. So what we're going to do now is to create the persistent volume. And to create the persistent volume, we can use the YAML manifest file. And I already have one here, which is in vi. I think I have it as pv.yml. All right, so this is a YAML manifest file for persistent volume. And I don't need to start explaining this from the scratch again, because I've explained this in one of our previous lessons. I've explained all the syntaxes of how a YAML file should be. And if you look at this, you can see that we have our API version to be v1, and the kind is persistent volume. This is the name of the persistent volume, which is pv-1. And if you look at the spec section, we have the storage class name, and I gave it a name to be static. So this storage class name is an important parameter that must be included in the persistent volume YAML manifest file. However, this is not a storage class object. So if you look at the capacity, you see that we have 13 gig. So the NFS shared LAN that we created was actually 13 gig. So you can make this to be 13 gig or lesser than 13 gig, however, whichever way you want it. And we also have access modes. The access mode is read write many. So let's even understand what access modes is. If you check the Kubernetes website, you will see the access modes. So for the read write ones, you can say that it's saying that the volume can be mounted as read write by a single node. So this simply means that, for example, if you have a pod running on different nodes, this means that the volume will only be mounted on one node as read write. So only one node will be able to read and write, while the other nodes will be able to read only. And for read only many, you can see that it's saying that the volume can be mounted as read only by many nodes. So this means that all the nodes in the cluster can just be able to read the volume only. And for the read write many, it's saying that the volume can be mounted as read write by many nodes. So meaning that the volume will be mounted on all the nodes as read write. And we also have read write once pod. And if you don't want to write it in full, you can see the abbreviations in the CLI mode. And also, you can see NFS here. So NFS is the type of persistent volume. So we have different types of persistent volume in Kubernetes and OpenShift, of course. So let me show you that too as well. So if you come here, types of persistent volumes. So we have the Ceph FS, we have the FC fiber channel storage. Like I said, you'll be the one to provision a remote storage, and if your remote storage is the one that uses fiber channel, of course, you're going to be using the FC protocol. You have the host path. So this is just like a directory on your node. And you can see, like I said, it said it's just for a single node testing only. So this is more or less like a local storage, like what I've explained. And we have the iSCSI, we have the local, we have the NFS, we have the RBD. So we are using the NFS type of persistent volume. And this is the NFS server IP address, and also this is the path for the NFS. So we can just save this and create the persistent volume. And to do that, I'll just say also create file pv.yml. So you can see that the persistent volume pv-1 has been created, and I can just do also get pv to verify that. So you can see that we have the PV being created here, which is PV-lon1. So this is the default one by OpenShift. All right, so now that we have our PV being created, let me just quickly explain a few things here. So if you look at, let me make this a little bit bigger. Let's see what I can do here. So if I do also get PV, all right, so if you look at this here, you can see that I have the capacity here. I have the access mode. Well, I'm not seeing it the way I want you guys to see it. Let me just drag this a little bit. 1 minute. Just want to see how I can make this a little bit bigger. All right. Okay, this is better. So the capacity, let me make this bigger a little bit. I mean, it's just to get PV. All right, so you can see that I have the capacity to be 13 gig, and that's the capacity of this persistent volume. And you can see the access mode, which is this read write many, and you can see that the reclaim policy is retained, right? And you can see that the status here is available, meaning that this PV is available. And you can also see that this claim here, there is nothing here. So it means that this PV is available and it has not been claimed by any PVC, right? And you can see that this is the name of the storage class, which is static. So let's even still understand what this reclaim policy means. Let's understand what retain reclaim policy is. So when a user is done with their volume, they can either retain the volume. So this is what it means. If your reclaim policy is retained, this means that when the PVC associated to that PV is deleted, or even when the pod that is using that PV is deleted, the data will still exist. So we're saying the persistent volume still exists and the volume is considered released. So that's the retain policy. And we also have the recycle policy and we also have the delete policy. So the delete policy simply means that when you delete a PVC that is mapped to a PV, it means that the data in the PV2 will also be deleted. So you can choose whatever reclaim policy you want to use, and you should also know that a PV to PVC binding is actually a one-to-one mapping. You will get to know more about it when we get to the PVC side. And I also want to talk about this storage class again. I can see that the name of the storage class is static. So it's just a storage class name, and it is a requirement in creating a PV. And the reason is because if you don't give a storage class a name, the PVC will be bound to the default storage class and not the PV. So if you do OC get storage class, you would see the default storage class. So that's why you would need to create a storage class name and give it any name so that it will not be bound to the default storage class. And even if you don't want to give a storage class any name, you can just use double inverted comma. That too works well. So now that we've created our PV, let's create our PVC. And for the PVC, I also have a YAML manifest file for that. So if I do vi, let me just do cat pvc.yaml. So if you look at this as well, you would see that I have the API version, the kind is persistent volume claim, and this is the name of the PVC, which is nginx-pvc. And on the spec, under the spec section, you can see that the storage class name is static. So the same name you gave in your PV has to be the same here in the PVC. And in the PV, we gave it to be static. We named it rather to be static. And so I'm just trying to say that we are creating this manually. We're creating the PV manually. So that's why I just named it static. You can name it, you can give it any name you wish. And also for the access modes, you see that we also have read write many. So the same access modes that you have in your PV is what you're also going to be giving your PVC as well. And for the resources, you see that we're requesting for the storage size of 10 gig. You can also request for any amount of storage size you want to request for. So now let's create this PVC. So I can just say oc create file pvc.yaml. So you can see that the PVC has been created. So if I do oc-get PVC, so you can see now that this is the name of the PVC and the status is that it's been bound, right? And it's been bound to this volume, which is PV-1, and the volume has a 13 gigabyte capacity. That's the volume that it's been bound to, and the access mode is read write many, and the name of the storage class is static. So if I do oc get PV again, you would see here that now you will see that the let me try and show you where the access mode, retain policy, status. So this is what I want to show you. You can see that the status now is bound. So it's been bound to this PVC. So now that we have the PV object and the PVC object being created, the next thing we're going to do is to create a pod that will make use of the persistent volume. Let me just clear my screen. So I already have the YAML manifest file for the pod that we're going to be creating. So I just have it in nginx.yaml. So if you look at this manifest file, you can see that it's following the same convention. We have the kind, which is the deployment, metadata, we have template, and here on for the container section, we have the container name and the image and the port. So what you should know is that you're going to be mapping the volume to the port first and then connect or attach or map the volume from the pod to the container that will be using the volume. And the reason is that a pod can have more than one container and you might just want a container in the pod to use the volume and not all the containers. Hence, the reason why the volume is mapped to the pod and then from the pod to the container or to a particular container that will be using the volume. And in this case, we only have one container in the pod. So what we're going to do first is to map the volume to the pod first. And to do that, of course, you can see that after the spec section here, we have the templates and we have the spec. So this is the container section. So I'm not going to be having the parameter under the container section, right? Because this is the parameter for the container. So I'm going to be having the parameter under spec section. So meaning that I want to map the volume to the pod first and not to the container, right? So you can see that after under the spec section here, I can have a parameter called volumes. So meaning that I'm mapping into the pod first. And for volumes here, I can have the name of the volume, right? So I can just say name. I can give it any name. I can say nginx volume. And after which I'm going to have the type of volume, and I can call it type of volume rather is persistent volume claim, and the persistent volume claim would have a claim name which we created. So I can say claim name. We created the claim name which is an nginx PVC. So by doing this, we've been able to map or attach the volume to the pod. Now we can now attach or map this volume from the pod to the container. And to do that, so that means we need to write these parameters now under the container section. So you will see here that under the container section, we have container name, image, port. So after which I can have volume mount, right? So here I can just say, let me leave a space. So here I can just say that on the port, I can just say volume mount, volume mount, right? Let me close it so you can really understand what we're doing. So volume mount. So for volume mount, I can have the name of the volume, and the name here. The name of the volume is nginx-volume. It's going to be nginx-volume. And the mount path, so this is going to be mount path is going to be, we're going to be mounting this volume in the path /usr /share /nginx/html. So the volume is going to be mounted in this path in the container. So now I can save this file. So let's create this pod. It's going to be file nginx.yaml. So you can see now that the deployment has been created. And if I do oc get pods, you can see that the container is running. So I can just put watch here till the container is being created. So the container is already running now, which is fine. So I can say oc get pods again. So the container is running. If I do oc describe, pod, let me just copy the pod name here. So if you look at the pod, the description of the pod here, let's see the mount. So you can see that this thing is mounted, the volume is mounted in /usr share from where? From nginx volume, which is read and write. And if you look at, let's look at the volume section, it should be somewhere here. Volume section should be somewhere here. So I can show it to you. Okay, so this is the volume section. So you can see that we have nginx-volume and the type is persistent volume claim. And you can see that the claim name is nginx-pvc. Alright, so what we cannot do is this. Since we have a shared storage being attached to this pod, so what we can do, or to this container rather, so what we can do is to create some files in this container and check and verify if that file is going to be written on the shared storage. And to do that, so let me just log into the container. I can just say oc, let me say oc get ports again. So I can just say oc, let me use this so that I can log in straight away, like the way we've been doing it before. I don't want to go through this crc node, so I'll just use this command straight away to get into the pod. So I'll just copy this and do paste. Let's say sh. Okay, saying this is deprecated. All right, so what I can do now is to go to cd/user/share/nginx/html where we mounted the volume to, and if I do ls, so I have some files there. So let me do touch test file 2. If I do ls, so now let's go back to this is the oops. Okay, I want to go back to the remote, to the shared storage, and see if we can, if we can see this file that we created. This is the remote. Yeah, so I can just log in here. So here I can do this is NFS share here. So if I do IP-A, so this is the shared storage. Let me confirm that here. That's the 128, and I'm in NFS share. So if I do ls, so you can see the file that we created, which is test file 2, meaning that even if our pod should crash, we're still going to have our data intact inside of our shared storage. So even if let's do something again. So let me just create another file. Say touch test file 3. I do ls, and let's see ls here. So you can see test file 3 here too as well. So what I'm going to do is to delete this pod. So let me just exit out of this. So I can just say oc delete file nginx3 nginx.yml. So this should delete the pod and say oc get pods. Okay, so let's even confirm if we still have our information intact. So if I do ls, so you can see that our information is still intact. So thank you for watching. In the next lesson, we're going to see how to use config map and secret, how to map those as volumes inside of a container. So thank you once more for watching, and I'll see you in the next lesson. Please don't forget to subscribe, share, like, comment. And if you do that, that would encourage us to do more of this. So thanks once more and bye for now. Hi everyone, Victor here again. In our previous lesson, we looked at the OpenShift storage or volume concept, and we created PV and PVC OpenShift objects and attached them to a pod. In today's lesson, I am happy to let you know that the secret and config map are also types of Kubernetes or OpenShift volume, and we already learned about the secret and config map object in one of our previous lessons. Hence, in today's lesson, we will look at how to mount secret and config map inside of a container as persistent volume. And the reason why we would want to do this is because upon startup, there are some applications, or rather, your applications might need to read up some configuration files before they are started or before some services attached to these applications will work. And also for secret, some apps might also need to read up some SSH keys or some passwords before they are started. Hence, we can attach these files or secrets as persistent volumes. So let's create the secret object first. And I already have the YAML manifest file, which is I have it as next secret YAML. You can see that it's following the same convention. We've already created secret before, so this is not a new thing. We've done this in one of our previous lessons. So you can see that we have API version, the kind is secret, metadata, that is the name of the secret is nginx rather dash secret, and you can see here that data and the name of the file. The auth key is the name of the file, and then this pipe, right, is showing that there is a content inside of the file, and this is the content. So if you wish, you can add more content inside of the file. So now we can create the secret, and to do that, I can just say secret file nginx nginx secret YAML. So you can see that the secret has been created. So if I do oc get secret, you can see that we have the secret being created as nginx secret, and the type of secret is opaque. So now that we have the secret being created, the next thing we're going to do is to create the config map object or component as well. And I also have that too in a YAML manifest file, which is in that's in the next config map YAML. So if you look at this file too, it's following the same convention: API version, kind, config map, metadata, the name of the config map, data, and this is the file name, which is nginx.extra. And this pipe means that I have content inside of the file, and these are the content inside of the file. And if I wish, I can also add more content inside of the file. So now I can create this object, this config map object. So I can just say create. You can see that the config map has been created. So I can just do get config map. You can see that we have the config map being created, which is nginx dash config map. And you should also know that this file's secret and config map has a number of data size it can accommodate. For secret it's around 10 MB. I'm not too sure about that, but you can verify that. So after creating the secret and the config map object, the next line of action is to create a container and map or mount the secret and the config map files as a volume to the container. So like I've explained, let's say you want to customize or overwrite a configuration file in the container. All you need to do is to make the file a mount path, right? And even if you would like to use the file by the time the container is created, you can also make the volume a mount path so that you can make use of it. And if the container too needs a configuration file or some sort of SSH keys, to start, you can also map this secret into the container upon startup. So, and that's what we're going to look at right now. So let's create the Nginx application. So I already have a YAML manifest file for that too as well. So I can just do cat hitting Nginx deploy. So you can look at the file here. So let me just do VI instead so that I can explain this to you. So this shouldn't be a problem because I took my time to explain this when we were looking at creating PV and PVC in one of our previous lessons. So if you look at this, of course, you can see that we have the API version, the kind deployment, the metadata. So like I told you in that lesson, let me just scroll down. I said that the way you would do this or the way you would map a volume to to a container is first of all to map the volume to the pod first, and from the pod you can then map the volume to the container. So the volume that we're mapping here is the secret and config map. So you can look at this section here that under the volume section, right, which is under the pod section. So let me just scroll up. You can see that after container here, after spec here, we have container and we have volume, meaning that we are mounting this under the pod section first. So for volumes, so you can see the name of the first volume. The name is nginx-secret-file, and the type of volume is secret. And you can see that this is the secret name, which is nginx-secret that we created. And the second volume that we're mounting to the pod, this is the name. The name that we're giving it here is nginx-cm-file, and the type of volume is config map. Unlike when we were doing PV and PVC, you can see that when we got to the type of volume, we wrote persistent volume claim. But in this case, the type of volume is config map, and the name for this volume or config map is nginx-config map that we created. So after mapping the volumes to the pod, then we can now map the volume from the pod to the container. And if you look at the container section here, you can see that under container we have name, image, pod, then we have the volume mount, meaning that we want to map this volume to the container. And the first volume we're mounting is, you can see the name, which is nginx-secret-file, which is this. And we're mounting it where in the container, we're mounting it in etc/auth key in the container. And if you wish, you can put this parameter read only, which is true, meaning that I want this file to be read only. And the second volume that we're mounting, you can see here, this is list of items, is nginx-cm-file, which is the config map here. You can see it here. And the mount part, we're mounting this in the container in the path etc/extra. So like I said, this is not a new thing. I took my time to explain it, and we even built the manifest file together. So if you're confused, you can just check that storage concepts, I think the previous one or the two previous lessons. So now that we have this, you have the SEMA manifest file. So let's create this um, container or pod. So now I can just say OC create. Let me just do this. I can just create this. So you can see that the deployment has been created. So if I do OC get pods, the container is still creating. If I do OC get pods again, you can see now that the container is running. So now let's see if those secret and config maps have been mapped to the container. And to do that, usually I used to log into the minikube node, but like I said, I can just go straight away. So this is going to be duplicated symbol. I can still use this method. So I can just say OC exit exec rather dash interactive shell, then the name of the pod. I can say let's say shell. So now I can do cd slash etc slash etc. So if I do ls, let's see if you can get the auth key file which we mapped to this container. You can see the auth key, and let's also look for the extra. So you can see the extra. So let's even see what we have. If I say cat auth key is a directory, so I can say auth key. Oops, you see the auth key ls auth auth dot key. All right, so I can see the name of the file that we created. So let me just scroll up a bit so you can see what I'm talking about. So here we have cd etc auth key, and the file when we created this auth key. Let's look at this here again. So we have the file name which is auth.key. So let's see the content inside of the file now. So I can say cat auth.key. You can see that this is the content. So it's actually an encrypted content. So it's just giving us what was encrypted, and this is the information in it. And also, the next directory is extra. So I just do pwd cd dot ls. So cd extra. If I do ls, so the file there is in the next dot extra. Let me confirm that too. It's as if, sometimes like, am I sure that that's the file? All right, okay, in the next dot extra. So I can just say cat next dot extra. You can see the information we have inside of that file. So this is how you're going to map secret and config map as persistent volumes inside of the container. And like I said, it's important for some applications. Some application needs to read up some configuration file before they can start up. And if you happen to have that kind of application, you can just create a secret or config map and then map it to that application, as persistent volume so that the application can start up. So thank you for watching, and please don't forget to subscribe to this channel, like, share, comment. And when you do this, you would encourage us to do more. And bye for now.